I need actually to have the Viz do it. Come up with this. Yeah. So what did you conclude about once you saw then that the sun goes around sort of the same way but in an opposite direction to the north? Where do you now sit with? What do you think? What do you think
He's
is going
answered
on
this
with
so
the
many
shape of the Earth?
times.
I don't think
Have
we've
you already
talked
asked
about
him
it
this
yet.
question?
What
I'm
did I
curious.
think whenever I saw it was upside down? Is that what your question is?
Yeah, well, what do you think about it now? Like, do you still question it? Are you working on a new sort of solution for that thing you observed? Are you just sort of, because it also sounds like you're a bit tired of it because people are maligning you for being a flat earther, and so you're missing out on like media opportunities and stuff, which I can see that. Is that causing you to question, or are you
I'm
questioning
kind of
for other reasons?
desensitized to that. I'm desensitized to that, to be honest. Like that ship has sailed. I just think it's flat, man. I can't. The rest of the evidence to me is like pretty conclusive, dude. Like, um, all the alleged evidences of the globe are not evidences. Like even going to Eratosthenes, right, where a geocentric glober suddenly thought the
24-hour
sun was
sun in the
93
south.
million miles away. Well, I'm just
24-hour
explaining
sun in
that
the
every
south
evidence
is better than Eratosthenes. They didn't
of
even know
course.
about the South Pole back then, right?
Yeah, it's not my point. My point is just like all the evidences that are proposed for it are lies. And this goes for like the motion of Earth as well. And so it's just like a conglomerate of lies and provably so. And yeah, the physical evidence of it just like doesn't match, right? Like I just saw another guy, he's not even a flat earther, and he just took like he took a camera that has like a huge like a super long lens or whatever, and he walked like 12 miles away. He should have been like so far below the earth, dude. And you so clearly see him. And I look at it knowing that if I believe the globe is true, I have to think that that guy's not really there. He's being refracted up 50 feet or whatever, and he's clearly not. And he had to stand in the perfect location because the zoom was like 400x or whatever. And he just where he's at, you know what I mean? Just one example. So yeah, I don't like it, just it is what it is. Like so now that I've seen different explanations, um and look, I'll say this too, like even my cosmological perspective is that this place was created and the heavens are like this are literally designed specifically to be something that we can't understand, and it's to make it undeniable that there's a creator, right? And
Oh,
it's
that's an
like we'll
interesting
never
take.
fully understand it. Yeah.
Oh, that's a fun take. So the creator is showing you the majesty in the heavens where they're like, this makes no sense at all. And that's how you know that you must be important and that I
Well, there's a
created this.
verse.
I like that.
Yeah, like like they
Yeah,
shows the
Psalms
handiwork of God is
19:1.
yeah, which is on the tombstone of Werner von Braun, right? But like even more than that, it's like the mainstream model also ends up there where they can't explain it. So like really no matter what you think, but the difference is the hubris of the one where they act like they know like exactly what it is in so many ways, and they just they don't. It's
They
all
have
like a
a
bunch
lot
of
of
guesses.
failed predictions about the heavens too. Whenever they looked up, the galaxies weren't making sense. The amount of matter that was there with the speed of the galaxy rotation, that didn't make sense. Then they have to invoke that 95% of the heavens is unknown, like some mysterious dark energy and dark mass that's causing it to move away from us and causing the galaxies not to fly apart. Like, so they don't understand 95% of the skies by their own metric and standard, and they expect flat earthers to have a full comprehensive model. It's
The other
crazy.
thing about it is like if the Earth is flat, and I said this on, so now that I say it, people are like, oh, that's convenient. You say that now because you went to Antarctica. Nobody, I have hours of dreams you can go watch. Right, I did schooling Globers for years. Right, you can go watch it. I've said the same thing for years. That on a flat Earth, the sky has to be in an apparent position. Like this is well known. I didn't have to go to Antarctica to know that we're not seeing the sun in its actual position, or the Earth can't be flat. It's just a fact. So I've known that for a while. But so like what the implications of that is like on a flat Earth, everyone has their own like personalized view of the sky. Like it's like literally like this place was created that wherever anyone is on it, they have their own like experiential perspective of the sky, and it goes with you wherever you are, which is a pretty profound idea if you actually think about it, especially knowing like the immensity of Earth. And if you think about like the progression of man, like now we think we have an idea of the totality of Earth, but throughout all of history, like where you were is where you were, really, for the most part. And then, some people from civilization would go travel on the boat, and some of them would die, right? You know what I mean? My point is like that resonates with me a lot. And the evidence seems to be pretty clear to me that there's like a containment, um, and that has a lot of implications if there's containment. So, like, I don't think it's a coincidence that if I put a dome over something and I start experimenting with light, if I layer domes, if I put any type of medium in there, like a fluid medium or like a superfluid or the optics we know of superfluid, like we get so many of the things we see in the sky. Like, I don't know, like, is that a coincidence? It would have to be a coincidence. If the Earth is a spinning globe, it would have to be a coincidence that I can like replicate sun pillars and sunsets and sunrises and apparent suns that are 24-hour in the south that go the opposite way and are flipped upside down, and the star trails at the equator are being straight but then diverging out, and nebulas and galaxies and the different colors of the moon and the eclipses. All of that can be replicated with dome optics and using like a
Can it be
superfluid and
replicated with
reflective
the
techniques.
same dome optics each time? Because the thing I think is that often happens is we go, oh, if you hold a fish bowl and you put water in it and you have a lamp over here, and we sort of concoct a singular test that kind of replicates a sun not getting smaller, let's say. But at the same time, it introduces things like a giant Fresnel lens in the middle of your vision or something like this, where I think you could use domes because domes refract light funny. What all of those would show that domes don't is that at a certain point in its path, it bends and warps, and in some places it's doubled and appears to, something that's a circle can appear to be a set of boobs in the right refractive thing because it wibbles and wobbles. Whereas we see that sometimes right down near the surface, you see a bit of wibbling and wobbling. But that's why I thought your test is such a clever one, because the sunspots are so crisp. They're definitely somewhere, and it's about an orientation. It's a clever test.
Yeah, I mean that's why it wouldn't be exclusive. I was surprised that none of the Globers came up with it because, in my opinion, it was by far their best test, right? But I really wanted to know the truth, so I obviously wasn't going to go there and not do it. You know what I mean? But so, and then obviously I made a point to them, and then they kind of worked with me. But really, it was mostly us getting like the northern latitudes done and stuff. It was kind of weird, but I will give props to I forgot the guy's name, honestly, the photographer guy that went with us. Um, forgot his name, but anyway,
I
he,
just
he
want
was
to.
like way more about
I
it
just.
than the other
I
ones.
just want to bring up real quick that Brenda's asking to be unmuted.
We heard that. I don't think Riggs wants Brenda unmuted because they're disrupting stuff. I posted the quote from the Dead Sea Scrolls, K4, Q 504 to 506. It's from the Words of the Luminaries, and the quote is, "The heavenly lights to their mysteries." And so there's like appointed mysteries to the lights in the heavens. And Brenda, I posted, I think in the side chat, the paper that the IQ or intelligence test was no different between conspiracy theorists and non-conspiracy theorists. I couldn't find a flat earth one in particular.
She argued that you can be a flat earther and not a conspiracy theorist.
Yeah, real quick. I gotta big up. Does anybody know who Ace McLeod is? You guys don't know, do you?
Request.
Yeah, big up. Well, just almost like I'm in like a moment of respect. R.I.P. to my boy Ace McLeod, one of the original flat earthers from Free Chan back in the day. One of the original motherfuckers that didn't give a fuck about these fucking crackhead globers, man. Respect to Ace McLeod.
How do you spell his name?
Ace McLeod. Ask Mark Sargent about him. You know what I mean? Everybody knows Ace McLeod. God bless him back in the day. I just ACE McLeod. I could put the obituary in, but I'm not doxing him. God bless his family.
What
Fucking
happened?
legend.
I'm so sorry. Rest in peace to him.
He just passed away, natural causes, but he was a legend. If you know, you know. Mark Sargent would know. You know what I mean? Like that's all the old heads would know. R.I.P. Ace McLeod. That's all I had to come and say.
So something real fast, dude, just because you brought this up, I don't want to forget it. The apparent sun thing too, like that's nothing for me at all. Like the size of the sun, the apparent size of the sun, because like to have a rainbow, like you can just Google it. It's going to tell you that you need the sunlight or light, and you need water, and then you need like something acting as a prism. You specifically need something like culminating light, and like an effective culmination of light is that angular size doesn't change. And actually, a Glober jumped on and threw his camera on and took like 4 dice along the table, right? Because all the Globers were acting like we made that up. So he just went and showed it real fast. And the dice furthest away, of course, was smaller. But when he looked through his telescope that culminates the light, all the dice were the same size. And so, like, if the sun, so from a flat Earth perspective, we can perfectly explain rainbows because we have the thing that's acting like the prism. We have the thing that's culminating light. There's a physical container outside. And that would also make it where the sun is not going to change angular size because of collimation. So, like I don't expect the sun to change angular size. This all goes into the same basket where the sky's apparent relative to the observer, and that there's physical containment that's collimating light and it's displacing it optically.
Would you agree
So,
that it displaces it optically? If it's displacing it optically, and I agree to that, the way it's displacing it always matches perfectly with what a globe should predict. There's bits of wibbliness around the surface and stuff, but the globe kind of predicts that. But particularly if we get to like whether the sun's going to be flipped, whether, let's say we discovered a new planet tomorrow, it would almost have to be orbiting eastwards and rotating eastwards with like high degree of probability and a medium degree of probability. Or like
You mean
the
circling around Polaris?
eclipses and stuff. Yeah, anything. Like, yeah, should we be pointing directly at Polaris, or should there be a wobble, or should there be, in fact, like 6 or 7 wobbles? All of those match, all of the ways, the mysterious ways in which you're describing the sky working are mysterious in how closely they match a globe.
Has anybody actually modeled out the eclipses like on a physical to scale model? Even just eclipses, like I'm still looking for this.
no,
Yeah,
but
let us know
like
how you go.
the globe was made from the sky,
Where?
bro.
Sure, I think that's probably partly true. Like we looked up to learn about ourselves, we look outwards to look inwards. Right, the Jupiter's pretty compelling, isn't it? With its little moon-looking moons that cast shadows and appear to be spheres orbiting spheres, and we can see that Jupiter's orbiting east, like rotating
Well,
eastwards.
no, not for me. No, like even if they were spheres, it wouldn't mean anything to me. But like, that's like that's the argument Alex Jones made to me. But that doesn't logically follow. Like the
Have you
Earth's in
met
the
Alex
center.
Jones?
Well, I debated
Yeah, we went on the show.
Harrison Smith. Yeah, and then Alex Jones jumped on there.
Sick.
And he
That's
talked about
awesome.
how he used to look at the sun. Yeah. But like so, and I'm like buddies with a lot of producers there. But the thing is, like if Earth's in the center of the universe, is really not even expected to be the same as whatever moves around it, right? But there's another test where a guy takes like 3 different mirrors, and they're different shapes and sizes. So they're like a triangle, a rectangle, and a square, or whatever, and they're different sizes. And it reflects the light on this cardboard, and like up close, you just see distinctly the light is the same shape and size as the mirror. But as he moves back away, they all turn into perfect circles that are the same size.
And
And
what
the
you're
bigger
saying
one
is,
is just brighter.
and what you're saying there is, we figured out using mirrors and stuff a way to match exactly how it would look on a globe. What I'm saying is, you can always do this, like find a fishbowl or do a thing, or a Fresnel lens, or something. But what we're always trying to do is match, because it happens to look, and what we're trying to match is what it would look like on a globe.
Well, no, I'm saying
Like,
this would be completely independent of a globe, right? Like even if Jupiter was a ball with moons moving around it, it wouldn't mean the Earth was. But like I'm
it'd
just
increase the
saying that
probability out of sight. Yeah, massively
maybe in your
increase the
opinion,
probability.
I don't really feel that way because you have to steelman
What
the
do you
other side, right?
mean?
Which is that the Earth's in the center of the universe and everything else is moving around it. So logically, you'd expect it to not be like anything in the sky.
What? That's
The
just
Earth is the only thing in the
that's
center of
starting
the
with your premise as the conclusion. Your premise and the
No,
conclusion is that they're
what?
different. You can't.
No,
Your conclusion is
the
that they're
point is that you have
different.
to
How do you
still.
reason to it?
No, The point is that if you're comparing the two, and you're saying we're always trying to make it match the globe. I'm saying no. If you're gonna try to make that argument, you need to still man the other side before just claiming that we're just trying to make it match a globe, right? If you
It
still
does match a
man a
globe, and
flat,
when you fix it, the way in which you fix it is to make it match a
no,
globe. That's what I'm saying.
no. Like if you're just gonna honestly entertain a flat Earth, it's in the center of the universe, right? That means it has a special and unique position. It's the only
Sure.
thing that's in the center, and
But you can
everything else is
reach that as a
moving around it.
conclusion. You can reach that as a
Can I
conclusion, but
throw
when I
one out
say,
there?
why is your conclusion that looking up, because the question here is looking at Jupiter going to tell us whether we might be on a spinning ball that's orbiting eastwards with the moons orbiting it?
No.
Then when we say, why is that bad? You can't go, well, because we're different to the skies, because that's what we're trying to test. You can't use that as the premise. You're trying to show that that is reasonable
It's a
without
natural
using.
observation, though. It's not just
It's
a
a natural
conclusion.
observation that we are not like the other things we observe.
Right,
Yeah.
You have to believe it's
Just assuming
impossible
the
to.
primacy of the Earth in order
No,
to
first of all,
conclude the primacy of the Earth.
if
That's
you're
what
going
I'm
to compare
saying.
two ideas, you need to properly represent both ideas to see which one's most probable. But beyond that, like ours is just objectively more probable because that's what the evidence shows. Like when we actually measure
Which
for
evidence?
motion, like measurement of motion, your paradigm claims it's literally impossible to actually detect or
I've got one
measure
for you
the
guys.
motion of Earth. So I mean,
Oh, no, it doesn't. That's not true. I'll show you a paper. I think it's eminently possible to detect the motion of
You'd
Earth.
refute relativity then.
No.
Nope.
Well,
It's just
can I throw?
which motion are you talking about? I agree. It's very difficult to detect linear motion. Absolutely. But
we're not
yeah,
talking
if you
about
want me to
rotation.
show
We're talking
you,
about
if you want me to
motion
show you
to Earth.
rotation, which is movement, it is physical matter moving.
Okay, I'm clarifying for you. I'm not talking about rotation. I'm talking about
Oh,
motion through space, but it doesn't matter.
well, if we're rotating,
Rotational is also dynamically and kinematically equivalent to a stationary Earth. Meaning, like,
no,
so when you bring up like that's what relativity says. So like
no, it
when you
doesn't. Not
talk
about
about like
gyroscopes. No, it doesn't. Nonsense.
relativity says you're incorrect, right? Not
Who's
only
relativity?
gyroscopes,
What
but
do you
also
say? What do you say?
stop interrupting me, dude. So not only gyroscopes, but also pendulums, the flattening of the poles, all this stuff. There's a dynamic equivalence. It's been written about in detail. Einstein himself conceded it. Einstein wrote a letter to Mach and it conceded it. I'm bringing up relativity because that's the mainstream model.
This is
Without
just
relativity, you can't explain Michelson-Morley. You can't explain Airy's failure. You can't explain Michelson-Gale-Pearson, which you would claim was rotational. You can't pick and choose and cherry pick things and claim that it's evidence and then dismiss the very theory that's needed to even claim your model in the first place. So I'm not being disingenuous here, right? You're trying to pick and choose. You're cherry picking an
picking and
evidence of
choosing. No,
rotation.
I can make a very clear distinction between them. There is a torsional motion, and torsional motion is always detectable because it is physical matter changing end over end. There's no way that you couldn't tell you were spinning 400 revolutions a minute in a chair. That is detectable with fundamental physics that I can feel with my hands. I don't need to pretend to be a scientist to go, I can tell if I'm spinning very fast in a chair. Whereas if
In
that
reference
chair
to
were
an
on a
inertial
well-greased,
lab. Only in reference to
if
an inertial lab frame, though.
if that chair was on a well-greased train traveling very smoothly across a surface, that I would struggle to detect. We're very clear that those are two different things. What you're talking about,
Yeah, but
Michelson-Morley,
you're
and
missing something, bro. You're
is
missing
linear
something.
motion, which we've already distinguished, and you
No,
keep
no, 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 no.
switching back
You're
to it.
missing.
You pretend you can't tell the difference between rotating and moving
No,
from one place to
no, no,
another.
no. First of all, your model claims that it is still rotational. Okay. It's called a curved linear velocity. It's relative to reference frame. It's free falling and curving at the same time. But set that aside, just talking about rotation. Yes, you're right. We can for sure detect and measure rotation, but it's in relation to an inertial lab frame. You're actually invoking the frame, the Earth itself, claiming it's moving. But even beyond that, right, a rotational universe around a stationary Earth in your own paradigm would also have a translation of motion to a stationary Earth that
That's
would
not in my
cause
paradigm.
gyroscopes to process. That would cause gyroscopes to process
That's not in my
pendulum.
paradigm.
Well,
Hey,
that
I've
is
got,
that.
Paradigm is
It's called the
ridiculous.
Machian. It's called the Machian principle,
I
and
reject
that's
it.
what.
Explain why I should
Then
agree
you
with it.
reject.
You're
Then you
cutting him
reject
off though.
relativity.
hey, can I throw one out
He's
there?
telling me what I need to
No.
agree with, and I'm saying, no, I don't agree with that. He
Yeah,
needs
well,
to
don't
show
ever
why I
get mad at
should.
anybody for cutting you off.
The reason that you have to agree with it or should
Okay.
is
Yeah.
because that's what is needed for relativity to be put forth If you
What are you talking
reject
about?
relativity, then you can't even claim a spinning globe.
I don't know what that means. That doesn't sound like you're talking with me anymore. So what all I'm saying is pendulums. Sorry,
What?
not pendulums. Gyroscopes
You're
are
not going to
invented by
address any of
Leon.
those points.
Yeah, I'm talking in the middle of doing it.
Oh, you
The,
talked
the,
over him
the
though.
gyroscope was invented by Leon Foucault before relativity, right? They had no idea about relativity. They still thought ether was a thing, and nobody had said it had anything to do with how gyroscopes work. He tried to detect the rotation of the Earth with the pendulum, decided the pendulum was a shit method, and invented the gyroscope. Thanks to him, we've got the gyroscope, which Einstein was well aware of. That by the time Einstein was doing his theories, we already had gyrocompasses that could accurately detect due north-south, not magnetic north-south, based upon aligning with the rotation of the Earth. And he was intimately aware of the devices because all of the physicists were nuts about them. What you're talking about is an ability to detect linear motion, which was predicted until Airy's failure and all of those that you mentioned, which is
No.
in question, was thought to be the case. But nobody ever
No, you have
questioned
one
whether we could
argument
detect
here, and so you
rotation.
just keep looping it and thinking I'm making it.
Well,
Because you
address
just
it.
have
I
one
mean,
argument. Your
yeah,
argument's the same one they had in 2016, which is that linear velocity is different than like a curve or rotational acceleration. I haven't made that argument once. Every
that's
time you
my
respond to
argument.
me, though, you just yeah, you keep making the same point. I've already addressed it, though. I said no, we're
You're
not
bringing up
talking about
Airy's
linear
failure, which
velocity.
is not rotational.
Oh
And I'm saying
my
they're different.
God, dude.
You're cutting him off. Can I share something
Throw
I
a
learned recently
linear.
about gyrocompasses?
Oh,
Sure, yeah.
man.
Okay, so if I build my own gyrocompass that doesn't have corrections, assuming I build it right, can it find north and can it have the latitude precession change? Did you
What do you
know
mean
that? No,
without
it cannot. A
corrections?
gyro alone holds an inertial direction, does not automatically seek north. To become a gyrocompass, it needs mechanisms that couples Earth's rotation and gravity to produce a north-seeking torque,
Yeah.
plus damping so it settles rather than endlessly oscillating. So, if you just build your own like basic gyro compass, like that just rotates, it will not be able to, it'll just keep spinning in a circle. You have to actually put compensation mechanisms to actually get to even
What are you
find north.
talking about? You're just saying if I've got to build a gyroscope, it wouldn't be a gyrocompass. Yeah. Gyrocompass is when you get a ordinary
It needs
gyroscope
directions.
and you hold it so you lock it to the vector of gravity. So every time it wants to tilt in a certain direction, gravity pulls it back down, and that will create a precessing force that if you are left of north will pull you right, and if you're right of north, it'll pull you left. It'll not fit, it'll feel out of kilter because it's compared to that vector of down. So you've asked an LLM, hey, if I turned off the thing that made a
Yeah, we're
gyro
not
compass
know
work,
them. These are from papers too.
You have to pre-calibrate it,
well,
is what
you've just
you're saying.
no, you just compare it to the vector
Yeah.
of down.
You
It's not
have
really
to
You're
that
not even
literally
difficult. I'm sure you've
calibrate
got to
understanding.
them.
calibrate them probably, but like that's not what I'm talking
You
about.
have
I'm just
to. You
saying
have to
the
have
function.
external computerization to make it work.
No, it doesn't. It's before
Yes.
computer. It's
Look it up.
1911.
First of all, there's so much that you said that's not true. Einstein never once mentions this in his writings at all. So you can claim he was
What do you mean?
intimately aware of it. He never once
Yeah,
invokes.
I gave you my reasoning about why he would be intimately aware of it. I'm not saying he wrote about it. I'm just
I'm just
saying
saying
there's
that's
no
weird
way
because
that
he
he
wrote about
was
everything
confused
else.
that gyros worked.
Let
He
him
wrote
finish.
about everything else. He wrote about everything else that had to do with motion, both rotational and orbital. Everything else. So whatever. He wasn't convinced of it. In my opinion, he would have wrote about it. But the point is, then according to you, if he already knew
Hang on.
about it, if
Hold
he already
on.
knew about it, dude, just let me finish. If he
Yeah,
already
I'm
knew
scrolling.
about it, if I'm granting your points, you're just like a
Right.
contrarian. So if I grant your point that he already knew about it, that's even
Mm.
more damning for you because he wrote a letter to Ernst Mach saying that in order for him to put forth his theory, he had to concede to the Machian principle. It was correct, physically required for his theory to even possibly be true. And in there, he explains that with a stationary Earth and a rotating universe, there would be real inertial forces as opposed to pseudo or fictitious forces, and that those inertial forces would absolutely cause the pendulum to precess. There would be a translation of motion of the angular momentum of a rotating universe around a stationary Earth, and you would get the same dynamic effects as a spinning, orbiting Earth. Okay, this is what he said.
So
So when you're invoking a rotating universe, just think about it. When you're invoking a rotating universe as the equivalent, then it's equivalent to what?
well,
A
well,
rotating Earth. It isn't about orbit, it's about rotation, right?
but what are you
Because
saying? Well, I don't. Machian principle is like if you rotate something in a viscous thing, like an atmosphere or a bucket of water, it will be able to transfer outside rotation to inside rotation. But there is no way that Albert Einstein thought that the stars or some outside Machian thing was making gyrocompasses work. I've just Googled it here. He did not just acknowledge gyrocompasses, he spent years working with them, served as a court-appointed expert witness in major patent lawsuits involving them, and even co-invented an improved spherical gyrocompass model, holding a share of the patent in 1922. So he was intimately acquainted with them.
Cite
And
it.
Sure. ScienceDirect.com.
AI giving you an answer to your biased question. You realize that there's AI hallucinations.
Direct.
I know you're reading an IA overview, so I'm
Okay.
just saying I've read
It
I've
is an
read more
AI
Einstein than
overview.
anyone. You
Sure, here's
interrupt
the
a lot,
paper.
bro. You interrupt a
Here's the
whole
paper.
lot, bro.
Well, you wanted the
Yeah,
evidence.
man,
and
you
that's what
gotta
you're-
you gotta
chill,
calm
actually.
down a little bit. It's a little bit too much over talk, man.
I'm happy to admit I'm wrong if you can show me a writing. I'm just saying I've read more Einstein than
Sure.
probably anyone in this room. I've never seen him say it.
It's in the chat. It's a research article called Albert Einstein's Expert Opinions on the Sperry versus Anschutz Gyrocompass Patent Dispute.
We're
So
in
that
it.
is him giving expert opinion in court on it, which is
On the
about as high
dispute
bar as
about a
you can get.
patent.
Well,
Okay, I'll
he's
read
got to be a
it.
recognized expert to go
What
into court.
section?
Both sides have to agree you're an expert in order that you're allowed to be an expert witness.
Taylor, we
but like,
can't hear what you're saying when you do that.
so you haven't read it.
I
Obviously, that's
literally
fine.
haven't
I'll
been
read it.
talking this whole time.
No,
I'm
I
just
just
asking what
googled.
section
I just
of the
googled.
paper.
Was he intimately acquainted with gyrocompasses? And yes is the answer.
Okay.
So there's
Okay,
no
so
way
I
he
already
thinks he
granted
can't
it.
detect the rotation of Earth.
Okay, you're wrong. I already granted it. So he thought that pendulums did it as well, right? The point
Fine.
is that he's saying it's not exclusive to a rotating Earth. This is the entire point. And that's why he conceded the Machian principle, which he originally rejected, by the way. But then as he worked through
Explain what you
relativity, he realized bro.
help me understand that. So the gyrocompass is a device that everywhere you read about it, it works based upon the detection of the rotation of Earth, right? Aligning with the axis of the rotation of Earth. And you're saying he owned a patent for that device in 1922 and is an expert witness in how these things worked. But he wrote a letter to somebody saying it's impossible that these things are detecting actual rotation. Is that what you're saying? Is that your case that you're making?
I'm explaining it to you. He invokes the pendulum specifically, and he's in his letter to Mach, which by the way was basically suppressed, and we had to go find it. But anyway, the point is that he wrote a letter to Mach. He invokes the pendulum specifically as an example, explaining now the a relativistic application of the Machian principle is called the Thuring effect, the Lentz-Thuring effect, and it invokes the frame dragging of space. Meaning that if the Earth is stationary and the whole universe is moving, you don't need a viscous medium like the air, nothing like that. That's not what the theory is. It's about space itself, according to Einstein. Space itself would actually drag, and the distant galaxies and all this stuff, because the fundamental principle was that Newton thought that the sun was the center of the entire universe. Now we know that's not true. So if you actually account for all the galaxies and all the stars and all the masses, if it was rotating around the Earth, that there would be a dynamic equivalence, and then they call it frame dragging in relativity, that would cause the pendulum to precess on a stationary Earth. And this is Einstein in his own words.
Right, but the question I'm trying to understand is it your view that, because do you agree, will you stipulate to or just grant that a mechanical gyrocompass is described anywhere you do it? If you Google it right now, it will say it is a device that finds true north or aligns with cardinal directions based upon the rotation of the Earth. You would agree to that, yes?
Can I make a comment on that? I just said it's like going to be a 2-3 parter. Corrections.
Say again?
Sure. You have to have damping and corrections in place.
Great.
Just
okay. Can I have an answer to the question though, Witsit? Would you agree that's just what the device is described as doing?
It finds true north based on the rotation of Earth.
It aligns. It's a compass that finds grid north, right? Is one thing it'll say, but the important bit is all of them will say, you will not find one unless it's wrong, that says based on the rotation of the Earth. What it's aligning with is the rotation of the Earth. Would you agree with that or disagree with that?
Yeah,
that's how the device is described as functioning. And so you're saying that he's an expert on this device that definitionally does that, and he later admits to somebody because of something to do with the Lentz-Thuring effect, which is, I'm reading here, a phenomenon in general relativity about some sort of space-time dragging. So
I just told you
because space-time, I'm just trying to connect them. How does that connect to a mechanical gyrocompass? Because mechanical gyrocompass to me is Newtonian. It doesn't need any relativity,
No, it's not.
if applied to it, won't have any effect on it.
Okay, I'll answer
math
you.
won't
So,
change.
like the Machian principle exists in Newtonian mechanics as well, but the reason that we have the lens theory is Newtonian's been thrown away. So, like, I invoked like the most up to date
I haven't thrown it away.
explanation, but Mach originally proposed it from a Newtonian framework. He actually invoked Isaac Newton, said, "Look, Newton thought the sun was the center of the universe, so he didn't even think about this, and we've overlooked it." Right at the time, everyone accepted ether and Newtonian mechanics. It was not until later until we got the Einsteinian mechanics, but so that's lens theory, which is the relativistic application. So it doesn't really matter if it's Newtonian or or Einsteinian. And then like a good work, if you want to see all the math of that, is like Andre Assis in relational mechanics, and he shows both Newtonian and dynamic equivalence of Machian principle. But the point is like the idea of it is just that if you have like they use a hollow sphere as an idea, as a thought like basically to proof of concept or whatever, a thought experiment. But the point is that if the universe is rotating around the Earth, then that's going to generate forces that translate to the Earth, and
And
that it will
you're
be equivalent to the forces generated from a rotating Earth. So when it comes to the pendulum, the gyro, the gyrocompass, all of them are the same.
So you're saying that Einstein was of the belief that because of the Mach thing, the idea of the universe frame dragging around us, like we're in the middle of a whirlpool, essentially. Your belief is that Einstein thought that would affect the functioning of a mechanical gyrocompass.
Yeah, he would have to because it's the same thing. But what then it was like a year or so before he died that someone else
But
sent
why
him
didn't he
word.
then? You're saying
What do
he
you mean
should
he
have come
did?
to this conclusion, this genius guy who I agree with on this, or I can't tell if you agree with the lens theory effect either, because I largely
No, I
throw
don't believe in relativity.
relativity out, right? He told me.
Well, you already brought
And
up he was intimately
it's
familiar
not
with the
relevant to me.
devices, so
Exactly.
when
And
he
he
was
didn't say that
generalizing
any of
his
the stuff
theory, you
Witsit say.
think he would might have brought that up if it,
He would have if it was
reflects
As like
his
relevant.
the
own
It's not
theory.
exception.
relevant, which is why he didn't. He was intimately aware of
If you-
gyrocompasses and he understood the lens stirring effect, and he never applied them to one to the other because there's no relationship. One
Is that what he
destroys
No,
told
the other.
you
They're
with
dude,
the
he
intrinsically
did.
gyrocompass
connected.
Or
version?
He also
terrestrial
didn't bring up
experiment that you could.
gyroscopes at all, bro. Like he just brought up the pendulum
Yes, he
as
did.
one of, not in the letter to Mach. He just brought up the pendulum.
Exactly. Because they were irrelevant to the
Because
letter to
all
Mach.
no, buddy. All physicists understand that if there's an actual dynamic equivalence, therefore the inertial forces go the other way. Any device claiming to detect this rotation of the Earth and the forces it generates would be dynamically equivalent. He would have to be a
What does that
retard
mean?
to list off every device that does that. That isn't how
What does
any
that
of his
mean?
writings are. What-
Describe the
Have
dynamic
you read
equivalence.
any
So
of Einstein?
if I'm in a car and I'm turning, and then I've got other cars going around me in a different direction, to explain how this is, I don't understand this dynamic equivalence. So I've got a gyroscope that is said to want to maintain its orientation such we can read changes in it, so we can get a view about what rotation is happening. Describe that dynamic equivalence as it makes sense to you. I don't want to hear about,
Okay.
so and so wrote a letter and I swear somebody else has done the work.
Okay.
You
You got to
Witsit, how
calm
do you
down though,
reckon it
because
works?
you're basically asking me to teach you things you don't know while trying to position yourself as though
I'm
you
trying to
know
get you to
more than
reason rather
me,
than
and
pretend
you're
it's already been
interrupting
solved.
me a lot. Think about what you're doing. You're clearly unfamiliar with this. You're asking questions that I have to explain
No,
them,
I'm
and you're
pretty
getting
into what we're
really
trying
like
to do.
antsy and interrupting a lot. So like it
Bro.
doesn't make a lot of sense, bro. You gotta chill. Okay. So
Can I
like
read
Dude,
something?
one
Eggs.
on just a second, man. On one hand, you're asking me what's my opinion. I'm happy to give you my opinion, but I'm pointing out that from your own worldview and what you're claiming to be true, you have to concede this.
No, I
Okay?
don't.
You
Because
can't pick and
I've
choose.
already,
You can't
but
pick
that's
and
just
choose, dude.
nonsense.
You can't pick
I don't have
Newtonian
to.
over here. You can't pick
So
Newtonian over here and relativity over here, or I'm just gonna
I
pick and
don't.
choose. You can't do that.
Here's what I'm doing. I said it. I largely throw relativity out, and I'll only pay attention to it if it should affect the things that I'm talking about, right? But I largely ignore it because Newtonian works. And when I Google what is the Lentz-Thurring effect and how it would affect the functioning of a mechanical gyrocompass, it gives exactly the explanation you did, such that you said, why are you repeating this? And then the next thing, practically, what's the effect on Earth? Well, because of this dragging space-time, blah, blah, if it was pointing off to a distant star, maybe over 1,000,000 years, it'd be a little bit. Practically, it has zero impact on how a mechanical gyrocompass functions on Earth. So you're telling me
What?
that,
Yeah,
that
let me explain
Einstein,
it.
who knew intimately about how gyrocompasses worked, thought they worked one way, then discovered the Lentz-Thurring effect, and then said, oh, they don't work, despite the fact nobody says that. Everybody says this works
Okay.
fine with Newtonian. It's just detecting rotation. You don't care about distant stars.
Okay, dude. Let me just first of all, when you say whenever I just pick Newtonian because it works, that's a pragmatic fallacy. We're trying to figure out what's actually true. Okay, if there's a spinning
Do
globe
you
flying through
think
space,
relativity is true?
no, but if there's a spinning globe flying through space, relativity has to be true. But set
No,
all
it
that
doesn't.
aside, when
Nonsense.
yes, it does. Yes, it
No, it
Holy
does.
doesn't.
shit.
Whenever
Can we
you're
just not
yes,
interrupt?
but when you're asking about like the star that it would basically have no effect, yeah, it's talking about within the within the paradigm of a moving Earth, right? Yeah, within a moving Earth, the frame dragging would have to be just the movement of the stars very far away. It would have basically no effect. So
Right.
that's not really the point. The point is a
But could
rotating universe around a stationary Earth would have a large effect. In fact, it would be dynamically equivalent to all effects that are attributed to the rotation of the Earth. That's the entire principle that Mach put forth and Einstein acknowledged.
so describe that
Can I
dynamic
please
equivalence, or
read
like
something
how
else?
it works, that we've got stars all the way over there and a gyroscope that could detect the rotation of a plane, but if it's affixed to a table, it stops detecting the rotation of the table and now detects the stars. I don't understand that. You just keep assuring me there's a dynamic equivalence. Could you explain it a bit?
Can I please read something? I've been trying to for 5 minutes. You cannot apply Newtonian equations to the gyrocompass. And here's an excerpt I tried to read to you before. Evaluation of mathematical models for gyrocompass behavior, error modeling and applications from N.T. Christo. Okay, in this it says, in this work we shall present the Lagrangian approach to the formulation of the equations of motion because this method circumvents to some extent the difficulties found in the direct application of Newton's laws of motion. The reasoning behind this is that Lagrangian's approach involves scalar quantities, while Newton's laws of motions involve vectorial treatment. So this is why you cannot apply Newton's laws of motion to the gyrocompass.
No, you're still applying Newton's laws of motion, but you're not, rather than using vectors, you've got to turn the vectors into scalars.
Wait,
You
so Eggs,
cannot
why
use
does the
a
Like,
lot
all
of
this that's
mechanical
saying is
gyro
like, if you want to model
continue?
it better, do it a different way. That's fine. Yeah, sure.
Wait,
Because
so Eggs,
scalars
why
can
does
be things like RPM is not a vector, it's a scalar. You spin it faster and faster,
Hey,
but it's
I just
that's
want to
not
ask you, Eggshells, real quick. Are you like in a hurry? Is there someone you have to be like very quickly? Because like
sorry.
we can make this conversation flow and we can let people get in if you let them, you know?
Yeah, I was just gonna ask real quick, why does a mechanical gyro continue to process in an airplane if it's not connected to the rotating Earth surface?
It's for its
Because the
horizontal.
plane's staying upright and the upright is rotating.
It's
Dang, upright.
for its
Yeah,
horizon. It's
plane keeping its
artificial
wings level
horizon.
to the horizon, right?
No,
What
well,
you're
because
saying,
earlier you were claiming it was processing due to Earth, the surface of Earth's like rotation, right? So if you're not connected to that rotating surface, how is the force getting transferred? All right.
well, because you're on something that's still rotating, you're going to keep your wings level. What you want to test is
No,
if I
airplane is
took
not
off
on
with a
something that's rotating. It's flying above it, right? It's above it in the
right, but it's flying
above
above a
the surface.
rotating thing, and if it didn't rotate with it, it would be slowly doing a barrel roll over the course of 12 hours, which would just be insane.
Okay, if you don't
So,
have damping, it's going to keep spinning. If you don't correct for the latitude, it cannot find the proper latitude. You have to add corrections and damping in the gyrocompass.
Sure, latitude, yeah, putting your latitude helps. Even if you get your latitude wrong, it's still pretty accurate.
It just keeps
Right, they
spinning
don't.
without damping. Like you have to damp it, or else it's never going to find north.
Well, it
Damping helps it find north. Yeah, what's the point?
I'm just
Why is that?
saying.
Why is that?
Kind
Why
of
would
basic. Like
damping
I
help you
can't make one
find?
myself.
Let's think about this. How does this
it's
thing,
for
all
your
of these
art.
things, it's got calibration, it does this, it does. Here's a really important question. You go, how do any of those things find due north, due south? It could point at the South Celestial Pole, even if it were 14 miles underground. That's wild, isn't it? This thing that just spins, and by
Why?
spinning, if the Earth was spinning, that must work that
it's
way.
pre-calibrated, bro. It's
Why
not
can't it
rocket
find
science.
south? It's
Well,
spinning
yeah,
on
sure,
two poles. It's
it's a
spinning on the
complex
north and the
instrument.
south pole. Why can't it find the south pole? That's a spin axis as well.
Yeah, it
It's
can. It doesn't even find the North Pole. It aligns its axis with the axis of rotation. The North and South Pole are
it's
equally
literally
valid.
it's for your artificial horizon. Quite literally, that's what it's for.
Well, the
The
real
best
problem
thing it's
for eggs
doing.
is why does it keep precessing when it's off of the surface? Because then, even in his worldview, there would have to be some sort of maybe a field, a gravitational well
Nope.
affecting it, right?
Plane just
Some
keeps rotating
immaterial
with the Earth. Like it's not that hard.
medium transferring forces.
Could a
Well, they're just
plane
claiming
fly
that
over
the
a
Earth
car?
is the plane's rotating with the Earth because of gravity, right? So it's like
No, it's
it's
just
it's
flying over the Earth while it rotates. Both are rotating. You could imagine a car fast enough that
you
a
just
plane could keep up, right?
denied that the Earth that
Jesus,
the
guys.
plane is rotating with the Earth because of gravity.
What do you mean?
Holy
It's
shit!
just you don't need to invoke gravity. It's just on a
Yes, you
rotating field.
do. That's supposedly what's keeping the plane rotating with the Earth.
Or you could say it's
That's the
rotational
answer to his
momentum it took off
question.
with. I think it would be rotational momentum,
Oh, wait a minute. So
rotational inertia with what you took with which you took off.
Wait, wait. You guys don't think that the plane is rotating with Earth because of gravity?
Like it's there's what is there? There's lift, drag, thrust.
Okay.
Like,
There's going to be gravity,
even in
which
your
is
paradigm, you guys have
weight.
immaterial field rotating the plane and the gyroscope.
Yeah,
So
All
there's
that's
that's
the
in
air,
same thing that
relation
you're
to the
there's
pretending to
air,
electromagnetic
experience.
which is
fields.
all
There's
that's in relation to the air, which is
that
supposedly
would
rotating with the Earth because of
that
gravity.
well, that would mean it would be a
but what do we
constant, then,
think
wouldn't
should
it? So
happen
it
with
would be a
like a
constant.
gyrocompass goes on a boat, but when it takes off, if it's detecting a rotation, if it detected no rotation because the plane's detached from the surface of the Earth, what that means is the plane is going to somehow know what its orientation was from 4 hours ago. And even when the Earth's surface is now no longer level to that, he's tipping his wings up in one direction or another to counter it, despite there being no value in that. The plane is designed to fly level. But for some reason, he's going to stick to his earliest orientation. For what reason? Like obviously it's like a car that doesn't touch the ground. It maintains the same orientation as a car that doesn't touch the ground. It's like saying, how does your car not know to flip over and over? Come on, guys. Can't depend on
What I
one of these
just gave
terms
you
for things.
your model's answer. It's pretty simple. Like, so I think he was trying to basically point out that you're invoking like something without like physical, like tangible connection or whatever. But like, I don't think you understand it. Like what I'm trying to tell you, right? Like Newton, when he put his stuff forth, he thought the sun was in the center of the whole universe.
Sure.
Okay, that's okay, and he thought space was absolute and fixed.
Mm-hmm.
If you fast forward, if the Earth is a spinning ball, neither of those things can be true. So Mach came around and said, look,
But can I ask
Newton
a question?
didn't know.
Can I
Yeah.
ask a question? No. Did he, while he thought that the sun was the center of the universe and that space was a background medium through which things passed, did he also think the Earth was rotating? Was he convinced of that?
Yeah.
Okay.
Yes.
So that's kind of important, right?
It
He
it
sets
was the
forth a set of rules.
1600s, dude. It was the
Yeah, he sets forth
1600s. That's the whole point. That was before all the other tests and discoveries. So we, of course, then found out the sun was definitely not the center of the whole universe, which was Mach's whole point. We also did tons of tests about the Earth moving through space that he had no idea existed, right? So Mach came around and said, look, everyone overlooks something. You like, yeah, it's true that his mechanics works if you assume the sun is in the center of the universe. But if you actually account for all the other masses, like the distant galaxies and all the stars of the whole universe, then there's a equivalence. If the whole universe was rotating, right? And that's invoking gravity, saying like if there's a Newtonian gravity is if it's true, but the sun's not the center of the universe, right? There's all these other galaxies and everything. If there would be like a equal and opposite dynamic equivalence akin to gravitation, which would have real inertial forces. It's just like taking a ball on a string and swinging it around with a stick. There you have real centrifugal force, right? Like the ball is gonna, if you cut the string, it's gonna fly off, and obviously the string is keeping it inward, which is basically being gravity in the analogy. It's being the centripetal force. So you have the centripetal and the centrifugal force. Those are real forces if the Earth's not moving, and though that's going to translate down to the Earth. What Linz Thering's doing is throwing Newtonian away, and he's saying, "Oh well, this is how it would work in relativity. It would be space itself." Actually dragging because you don't have absolute space like you do in Newton. So if you pick Newton, you have much more problems, honestly, because then you get the Newton bucket experiment and all this stuff. but the mainstream model doesn't invoke Newton. And it's kind of like saying, I choose to just use Newton for the gyrocompass because it works, is the same as saying, well, I just use Newtonian gravity for the planets and their
Both
orbits
give the
because it
same
works.
answer. My point is both give
Yeah,
the same.
but
Like,
that's-
here's what's wild to me about this conversation. You don't believe in relativity, and I say I don't need to invoke it for this thing. And then you demand that we still try to explain it using relativity, even though I claim that I can show this to be true without it. And you don't think it's true. So you require me to show something that you think is untrue that isn't central to my argument. Relativity, my point keeps being just this. All of the things you're saying, I think, are very true. There's lots of mysterious stuff that, if Einstein's to be believed, is mind-bending. And frankly, I don't spend much time thinking about it because all that relativity stuff about actually it's over here and it's back in last Tuesday and your brother gets older than you in space is just sort of science fiction nonsense to me. And all of the people who do believe, let me just finish this. All the people who do believe in that, and all the people who do think that gyrocompasses work, many of whom are overlapping groups, are very confident on the fact that I keep saying to you that this Machian principle and stuff that you're trying to suggest that the universe is making a gyro work forgets the fact that gyros work in every other context. If you get a very slowly moving, rotating thing at a mine or something, and you put a gyro on it, it will detect that rotation and the Earth's rotation. So what it's outputting is clearly rotation. And you're saying, well, Einstein wasn't aware of that and accidentally was an expert about devices that detect Earth's rotation while also championing a theory that you, Witsit, don't agree with, that you think I should agree with, that you think his theory says that gyrocompasses that he was expert about didn't work on Earth's rotation. If you look at what he really said, it actually means that he was an expert in things that are false.
You would never let him talk this long. You would never let him talk this long.
The part of relativity that you're abandoning is relied upon for heliocentrism. So that's the real.
None of it's relied. My point is none of it's relied on for the gyrocompass. None of it's relied on
He
for the
didn't interrupt
mechanical
you, by the
gyrocompass.
way. Let him respond.
Yeah. Okay, so
You
first of all, the
interrupted me.
reason that I keep on bringing up relativity is because you can't invoke a spinning globe with Newtonian dynamics. I could give you a list of 50 different reasons why that is. If you disagree with that, that's fine. I gave you a couple. Michelson-Morley is a great example. You just have to have relativity. You can't pick and choose.
Hey,
That's relativity.
hey,
You
you just talk forever.
You can't pick and choose. Okay, so
Yes, you
you're
can.
just
If
saying,
I show a difference, I can.
stop interrupting
Bro.
me, dude. You can't pick and choose. And your response was, it gives us the right answer. You're conflating like science and math. The explanation of what's actually happening, is it truly viable? Is that what's really going on in reality? Like an actual explanation of how it works, like dynamics, and then kinematics and mathematically describing it and getting the equation that works. Those are different things. Like that's why I brought up, yeah, people always say we're just going to use Newton for satellites and planets because it works. It's called a pragmatic fallacy. It isn't true because it works. Because in your paradigm, you get the same answer with relativity, but when it comes to
Not what I'm
actually
saying.
explaining it in terms of physics, it has to be relativistic. That's the reason I'm bringing it up. But my point exists whether it's Einstein or Newton. Mach's principle applies to both. So you would get
Mach's
a
principle.
dynamic equivalence.
So Mach's principle applies to Newtonian only through drag, right? Actual particle collision, correct? The only way to make Mach work with Newton, which it does, like that's where it's first theorized, right, is about spinning a bucket and the outside walls of the bucket moving the outside water particles such that eventually they transferred that rotation all the way into the center, that eventually they would all be spinning at the same speed and have a big wall up the side of a bucket, right? A horseshoe shape inside the bucket, correct? That's the Mach thing, right?
No, and that's not completely unrelated, but no, they're different things. But like it's
What is the Mach?
sure,
What
sort
can
of.
you explain the Machian thing then? But that'd be my understanding the whole time. This is obviously why I'm not understanding you.
I mean,
Tell
it's
me
not
why
completely
Machian is.
unrelated. If it's very simple, like if the whole universe is rotating around the Earth, it's going to generate real inertial forces that's going to translate to the Earth. If you
How?
actually look at what Newton said, he said there has to be a medium, right? And whether that medium is material or immaterial, he's left to the consideration of his readers. But that his theory is impossible without an ether, effectively. This is why all of physics accepted both Newtonian mechanics and the ether all the way up to Einstein. And in fact, if you had suggested that either one of those weren't true, you would have gotten laughed out of the room. They were joined at the hip.
So
So
Machian
once you
principle applies to ether, but Machian principle is about is about particle collisions transferring inertia into rotational inertia.
No, it doesn't have to be particles at all.
So what's the ether doing then? How's it
It would be
working?
the
Why
same
is it
thing that
affecting
Einstein claims that space is doing.
But how's it affecting a spinning mass? A gyro is a spinning mass that they had before they knew about relativity and before they had computers. They had a spinning mass finding the axis of the Earth. How
Okay, it'd be the same way it
is
affects the
the
pendulum.
ether doing that?
Same-
That's just saying, there's both things that look like Earth spin turn out to be ether. Ether ends up looking like a bucket in which we put all of the I don't know answers for the flat Earth.
No, the analogy would be like a whirlpool.
Real quick, gravity
whirlpool is
is
particles.
working at a distance between it's basically a medium that has no substance, which is like an oxymoron. How do you have spooky action at a distance, or how do you have gravity affecting things in large scale, at cosmic scales, with no intermediary?
Yeah, it's spooky.
You have the same problem.
I think I think it's very spooky, and you're right to say it's spooky. I don't think then you're right to go, by the way, I've also got a spooky one for you. If it's spooky, it's spooky. Don't use it.
No, so you said, I brought up the analogy, you said it's particles. It's like, that's not the point. The point is that it's a medium, right? The water is a medium. If I have a whirlpool of water, if you stand in the center at the bottom of the whirlpool, you're going to feel it. Okay? And that's a translation of motion through a medium. No, you can say it's because of particle collisions. That's inconsequential to the point, because again, this is why I brought up relativity. It's like they claim space is doing that. Frame dragging. It doesn't matter if you interpret the medium as being collisions of particles or not. A medium has to translate motion.
Why? But
So the methodology of
I don't even
that's
understand
just how it works.
I don't understand.
But
I don't think
hold on,
there's a medium.
can you answer my question though? You didn't even answer my question. Selected. So how is gravity affecting masses at a distance? Like, what is the mechanism?
When do you ask that question?
I just asked it, dude.
Oh, so yeah, I think my answer to that is it's spooky. Like, I think things can. I've seen magnets work, but if I thought it was spooky and that's why I rejected gravity because it's got no evidence and it's spooky, I wouldn't go, oh, by the way, my solution is equally spooky. I would.
Well, we're not denying phenomena though. That's the thing. Like, you're basically saying, oh, prove it. I'm like, well, you haven't established yours. We just know it's the property of reality. Like, this is a parallel, just in a different paradigm.
Right.
They're equally unanswerable at the current time.
So the ether would act on the medium
Here's how it
itself?
affects the gyro. Here's how this ether that is immaterial, it's not particles, but it's behaving like particles, but it's only behaving like particles against things that are trying to detect the rotation of the Earth.
I can tell you what they said it was. The luminephorous ether was to act mainly as the medium in which lights and electromagnetic waves vibrated. And so moving the medium itself is kind of how it moves. The same way that they say that gravity works because space-time is bending. That's my understanding.
Yeah, it's like you're essentially appealing to like the properties of gravity, which, like we've just accepted your story, like, and we accept there's a phenomenon, but you're kind of like exonerating your phenomena, which is the mechanism for the claim of the Machian principle. Like, we're willing to accept the effect regardless of what the explanation is. You're just saying, well, you have to explain it, but your story isn't proven either. So.
And the gyrocompass, you have to add all.
No, I think my story is proven. My story is
work and find true north.
Do I need to read it? Do I need to get like AI to say it? If I read it from Google AI, will you believe it?
Well, you're just scattergunning. And none of these are addressing the point. The point is we've got a spinning mass that wants to align with the axis of the Earth, and that at a gut level should feel like it makes sense to everybody, that we don't need to make up nonsense about relativity. We just go, I can see how a gyro would want to lock on. If it was attached to a spinning body, you could find a way.
No one said they don't understand
that, lock bro. On. No, it actually keeps spinning.
Does.
The gyrocompass does not lock on its own. It keeps rotating over and over. You have to add damping to make it lock to north.
Is it a gyrocompass if it doesn't find north? You're saying it's
no, it would be just a regular.
Then it's not a gyro.
Yeah. There's a difference between gyrocompasses and gyros. Yeah, gyrocompasses have the dampening, or they have a counterweight that actually uses the torque. But this is the thing, Eggs. We're not denying, right, that possibly, right, the Earth rotating could be the causing the effect that we see in pendulums or gyrocompasses. But if you say that's the only possible cause, it'll be affirming the consequence, or begging the question, right? Which we're not doing that. We're saying that there's this other possibility with Mach's principle that could be causing the same exact effect.
Just like particle collisions, but we can't find the particles. We don't know what they're made of, and they only affect things that are attempting to detect the rotation of Earth. They're not.
I can't find gravity either, man. I've already explained
we
this.
don't need ether for computers.
Yeah, where's
or
the
internet
graviton?
Or
where's the graviton?
semiconductors or planes. We don't need it for TV. We don't need ether for anything except explaining away the rotation of the Earth.
Eggshells, brother. You
theory.
believe in gravity? You believe in gravity that acts at in like insane distances, that it's effectively doing the same thing.
Like a magnet.
Like
like a magnet.
it's bodies acting. Stop interrupting. Bodies acting on each other over immense distances. Where's the particle? Where's the graviton?
Force. I can detect it with ferrous. I can find ferrous things and say this is ferrous, this is not, because it reacts to magnets. Done. I can
No, we're talking about gravity.
Fine, yeah, I can detect masses. What's the difference?
No. Where's the graviton? Where's the fundamental particle?
It doesn't need to be a particle. If I'm invoking something that acts at a distance, then I won't say Mach's principle, because Mach's principle in the Newtonian sense is about particle collisions. What you're talking about with frame dragging is about the delay of the light, so the star looks delayed in its movement because it traveled from a different path as you moved through the universe to meet it in a different spot to where you were when it left, right? It's this really weird relativistic effect that a spinning gyroscope doesn't care about. It works exactly the same either way, which is why people who understand relativity aren't confused by gyros.
I'll read Google for you. Mach's principle states that local inertia is determined by the total distribution of matter in the universe. On a stationary Earth surrounded by the rotating distant stars and galaxies, the revolving universe creates a powerful gravitomagnetic field. This field exerts forces identical to Coriolis and centrifugal forces, forcing a gyrocompass to align with the rotating cosmic mass and read true north.
Gravito. Say it again. Gravito. No. I just want that one word.
Gravitomagnetic. And this is where I told you about.
Please explain the
I told you about. Well, I told you about Andre Assis, and he shows the math. And in the math, if you do the dynamic equivalence, then it comes out to be. Stop interrupting me, dude. You don't know about any of this.
Point. I want to just focus on that part of your point.
You don't know about any of this.
Gravito.
You don't know about any of this. You don't know about any of this. You don't know about any of this.
I know. I'm asking you to explain that bit, not the dynamic equivalence. I've heard you say that 1,000 times. You said gravitomagnetic. What the fuck is that? Please.
I'm explaining it. I'm trying to explain it to you. So just like if you look at the relational mechanics equations where he shows the dynamic equivalence of both Einstein and Newton of a stationary Earth, and he uses the pendulum and the flattening of the poles and all this, and he gets the exact same predictions. Exactly the same.
What
and
is
it comes out to be exactly, stop interrupting me, dude. It comes out to be the exact equation of Weber's equations, which is the electrodynamic force. So in their paradigm where they're assuming gravity to be the cause of everything, they're calling it a gravitomagnetic force, right? Because they're just claiming that basically, according to gravity, there would be a dynamic equivalence. So if they're saying that the distant galaxies are causing this effect on the Earth, they're going to invoke gravity. Right, and then the actual math just shows you the electrodynamics. What
is this your answer to why it affects a spinning gyroscope is a gravitomagnetic force? I don't understand.
I wouldn't call it that. No, I would say maybe it's electrodynamic, but in general, it's really simple. In my paradigm, it's like there's an ether, there's a rotating universe that creates real inertial forces. Centrifugal force is real. It's not fictitious like you guys think. The centripetal force is real, and then you just have a net radially inward accelerative force. It would be detected on the Earth. It would have to be.
Would
literally
That's
have to.
part of general relativity. Is this gravitomagnetism? It's the analogy to ordinary magnetism. Moving or rotating mass energy produces tiny effects that influence the motion and orientation of nearby objects. Its most familiar manifestation is frame dragging. Lens steering effect. It's interesting.
Sure. So could you Google after that, how would that be proposed, or how could that affect the functioning of a gyrocompass? Would that affect or have any bearing on whether Earth is turning or whether it finds the axis of the rotation of Earth?
I want you to know also gyrocompasses do not work at the equator or at the poles.
They do work at the equator.
No, it doesn't. Look it up. They don't have any torque.
You've looked it up wrong. I'm sorry to tell you. It's not.
The precession,
100%. It's 100%.
No,
You don't get
torque
any more
and
torque than at
precession
the
are
equator.
0.
You've misunderstood it. I'm sorry.
Oh my gosh. They're 0 at the equator, and they rise to 15 degrees per hour at the poles.
Okay. If I Google it and it says gyros work perfectly well at the equator.
The North
So are you saying it's backwards?
For the artificial horizon.
No, hold on. Eggshells, do you think it works better at the poles or the equator?
Equator.
Gyrocompass.
Equator.
No. Well, the torque is 15 degrees per hour, but that's approaching the poles. At the equator, the precession or the torque is essentially 0. It's the same thing for the pendulums. Why the pendulums don't have any precession at the equator.
Yeah, that's not right. How could it be less?
Yeah, that's not right. Look it up.
Yeah, torque means rotation. All of the Earth has to have the same torque. We're all turning together or not. You can't
What
have
if you
different
learned
parts of torque.
otherwise?
Because if you had, that would mean different parts of torque on an object means a same object was turning at different rates. It'd be like a, what are those slide puzzles? Rubik's Cube, right? Where one part was turning and another part wasn't. We're one object. We all have the same torque. At the equator, it is much easier to detect because you want to keep the base plate of the compass flat so it's pointing upwards so you can read it. And then your direction of gravity.
North-seeking torque.
And
it's what you need to look up. The ability to find north is 0 at the equator.
Okay, well, I've got it on my screen and I say, do gyrocompasses work at the equator? And it says, yes, gyrocompasses work at the equator. In fact, the directive force, the tuning force of the Earth's rotation that helps the instrument seek true north is at its maximum strength at the equator.
Look it up. No, I guarantee you.
I've got it on my screen.
Yeah,
I've looked it up.
you can share the source of whatever you're reading, but I can guarantee you the torque ability to find true north is effectively 0 at the equator. It approaches 15 degrees at the poles. Same thing with the pendulum. Are you familiar with the pendulum, how it has no precession at the equator?
So that one I can't speak on much. At the poles, the gyrocompass gets worse because what it's trying to do is compare down and use down to hunt for the axis of the Earth and then align with that. So if you're at the equator, the axis of the Earth is horizontal to you. So the north-south bar on which the axis spins that it's trying to align is already horizontally aligned with the Earth. Now it just needs laterally to line up with that. As you get closer and closer to the pole, you're trying to find something that's closer and closer to vertical with the bar that's in your gyrocompass stays roughly horizontal. So it becomes a sharper and sharper angle. So the torque is 15 degrees per hour everywhere, but the ability to detect it gets harder and harder and harder as you get really up near the poles. But you don't want to use, you're near the pole anyway, you use a different kind of gyro to find the North Pole.
No, it changes with latitude. This is the latitude dependent effect.
Sure, it changes with latitude, but it's not 0 at the equator. It's most effective at the equator. Most effective at the equator.
What is most effective?
The gyrocompass. It's the torque available for it to get its reading is at the highest it can get at the equator.
No, it's not. It's a 0. Same thing.
Show me. I've got the cultofc.com on my screen. If that'll be enough for my one, you tell me. I've put it in the chat. You tell me where you get the idea that a gyrocompass has 0 torque at the equator.
Okay, I'll share with you.
Okay, so, and this is the thing that's super frustrating when people just try to like cherry pick Newton. It's super goofy. Like I went straight to the Thirring effect because that's just what your side has to invoke, right? And when you look at Hans Thirring solutions to Einstein's field equations, which means it's not negotiable. This isn't like a
What's the
situation.
Thirring effect I have to invoke? Tell me about it and why I have to invoke it.
If you invoke relativity, you have to invoke it.
I don't invoke relativity.
Okay, so then you can't. Then how do you explain Michelson-Morley?
I don't. I'm not talking about it. That's linear motion. I'm talking about.
Okay, so you just put your head in the sand and cherry pick phenomena you think is consistent with your bias and your worldview.
It just sounds like
and
you can't discuss a gyro.
No, that's not true. The point is that it makes me retarded to have conversations where I know that it isn't in any way going to actually get us to the solution of what's actually going on because you're cherry picking phenomena that isn't consistent with all the available empirical evidence. That's what you're doing. And you're saying, oh, this test over here, I can't explain this test or this test or this test or this test with my Newtonian gravity. But I'm going to ignore all that because I
Which
think it's
test?
simpler and easier to explain this other thing. Michelson-Morley.
But what test? But that is a test. If my case rested on that test being true or false, then you're right. But that can be true and gyros can work. That can be false and gyros can work. It doesn't intersect with how gyros work. So I don't need to. The point I keep making is we don't need to discuss relativity. I can agree with it or I can disagree with it, and then we can come back to the gyro. So I'm saying it's not probative to whether the gyro is finding the rotation of the Earth, unless you can show
That's
that it is.
incorrect.
You're saying it is. Okay, so show that it is.
Yeah, you're invoking gravity.
Sure.
Intrinsically.
Yeah, there's a vector of down.
You're invoking gravity. Specifically, you're invoking Newtonian gravity.
I'm just saying there's a vector of down. That's all I'm invoking. If you want to have a conversation with me and what I am saying, I'm just saying there is a vector of down. Deal with the vector of down.
Okay, so you're asking me to just like argue with you about the gyro compass from like a kindergarten level of knowledge, to
No,
go
I'm
back to
saying have a real
1600
conversation.
and pretend we don't know anything about what's required to actually propose the idea the Earth is a spinning globe, and then cherry pick the gyro compass out of it. So that's like it's literally debating just to argue. It's like a contrarian
No, it's
thing to
just
do. And
we agree on a vector of down, right? That's all we need. We don't need
Yeah,
gravity.
but both sides would have an equal amount of unknown. I've already indicated this. Like you would have to, I mean, unless you say otherwise, which you claimed otherwise, that you have proof for your side, then we move to graviton, and you just want to keep talking about the compass and not the gravity part of your claim. Like, because otherwise you don't have the mechanism. Like the thing that you say that we're just inventing, you're invoking.
No, we've both got a vector of down. That's all we need. That's all that's relevant to the conversation. You're trying to change it to something about
then we have an equal burden. Yours is just as ridiculous as mine.
But you don't even have an answer. I've got a device.
You don't even have an answer either. Where's your graviton? You see the problem?
Where's the graviton?
I've already pointed this out like 20 minutes ago.
Where's the graviton?
If you don't have functional components, then your idea is shit.
I don't need the
because
graviton.
my idea is shit, so yours shit too. Then.
But you
no, your paradigm claims there has to be a particle of gravity. They've been looking for and can't find it.
I don't claim that. You have to shadow box.
You said that you have evidence for your paradigm, but it's not there.
I do. Yeah, it's the gyrocompass.
You can dismiss the ether if there's not a particle, but you can invoke the gravity without a particle. So you can do whatever you want. You can pick and choose Newton and Einstein. You can pick and choose rotation and orbit. You can pick and choose particles. You can pick and choose mechanics. You can pick and choose needing gravity, not needing it. Whatever you need to pick and choose, to cherry pick to make some random weird argument that, when actually put in place with all the actual evidence, makes no sense at all, completely collapses on itself and is a non-point, but want us to go back and forth with you as though it's a real point because you cherry picked it out. And
everybody knows it's a banger point. When the person you invoke to debunk it, like let's lay out your case. Your case relies on using relativity to debunk me, despite the fact that you don't think relativity is true and I don't require it for my argument. The person you used, let me finish. The person you used to debunk me with relativity is Einstein, who is acutely aware of these devices such that he owned a patent for them. And you want me to believe that something frame dragging, it means that gyros do not detect rotation of the Earth, despite the fact that is what they say they are, and he was an expert witness in them. The person you're using to debunk me, who you don't believe in, who I don't invoke, disagrees with you. That's how bad your case is.
No. You straw man me, right? You straw man me. You're going to interrupt me.
Which bit's wrong, though?
Look at you, dude. You straw man me. Okay. I'm not invoking relativity. I'm saying that within your own claim, you have to do that. So it doesn't matter if you do. You can't invoke the modern model.
Yes or no?
You can't invoke. You can't invoke the modern model of Earth without it. Doesn't matter how many times you say no. No, you can't.
I don't need relativity, and
you objectively can't.
Who brought it up first, Sage?
Oh, no, everyone knows I brought it up because I had to teach you all about it. Yeah, duh. So the point is, you're asking us for an alternative explanation. We don't need Einstein or Newton for any of that. A stationary plane Earth, because I'm explaining in your own paradigm, it's not exclusive evidence.
Sure.
And
so
you don't
you're bringing up a
understand
thing
that.
you think is false, rather than just discussing the guts. Because we don't even need Newtonian. We could just talk as humans about how we get the gyroscopic forces. We can feel.
We're trying to get into the guts, and then you said we can't do that.
Nope.
Like the guts would be the graviton. The graviton would be the comparable to like what you're asking for. Like you want to talk about the
graviton exist? this is a huge point, okay? I didn't only bring you relativity, I brought you Newton, relativity, and relational mechanics that does away with both Einstein and
You
Newton
couldn't
and
explain
any
it.
claim about space. Stop interrupting me because you don't know anything. It throws away absolute space, it throws away space-time, it says screw space. It's just a concept. That's what Andre Assis says, and he shows relational
Do you
mechanics.
say
Throw
that?
all of it out. Stop interrupting me. Yes, he literally said space is just a
Did you say
concept.
that?
Whether you think it's fixed and absolute or not doesn't matter. And he throws it out, and he promotes
Fine.
a new type of mechanics. So not Einsteinian mechanics, not Newtonian mechanics, but what he called relational mechanics, and said that the
Okay.
actual physical objects, the matter itself, was going to cause a physical interaction of inertial forces. He throws out both Newton and Einstein. He throws out both fixed space or not fixed space, then shows the math using
Does-
Weber's
Well,
equations, which is electrodynamics of a stationary Earth and a rotating universe around it, to explain every phenomena on Earth that is
but you can't
attributed to the
explain
rotation.
it.
I'm almost done. Every phenomenon
It's
on Earth
long.
that's attributed to the rotation of the Earth,
bro.
and specifically shows you the mathematical predictions of each of them, and it gets it exactly right.
So
Okay,
he
so we
gets it
do
right.
not need
He gets
all
it
of them
right.
get it
Whoever
right.
this new guy is that you've invoked, who's the next in a long line of guys you've invoked, who I swear can put this whole argument to bed, you're sure he's got the argument. You're sure he can do the maths. And that's good enough for us. We need to know that you know it,
No,
despite you not being able
no,
to do any of that stuff for us now. Why don't we
you're
have a
lost.
discussion, you and I, Witsit? Why don't you talk to me about what you think, and I talk to you about what I think? Every time I ask you what you think, you tell me
Oh,
about some other person who invokes some other thing that we don't even get our teeth into. What do you think's going
you're
on with
just
the
not
gyro?
understanding.
Honestly, what do you think's going on with the
Okay,
gyro?
okay. I'm gonna tell you what I'm gonna summarize that point in 10 seconds, and I'm gonna tell you what I think. I
Okay.
just gave you Andre Azizi shows the math of both Newtonian, Einsteinian, and relational mechanics. They all show a dynamic equivalence, completely refuting your idea of
Fine.
exclusivity. Objectively, if you don't understand it, not my problem. On a
I don't
stationary
have an
plane Earth with
exclusivity clause
rotating,
still.
on a stationary plane Earth with a rotating universe and an ether, all of no matter how far away they are, no matter how big they are, the galaxies, the stars, the quote unquote planets, all of those masses rotating around a stationary Earth within an ether would cause a translation of inertial forces. The angular momentum of the rotating universe would necessarily have to generate real inertial forces, specifically centrifugal and Coriolis forces, which is effectively a centripetal force, and even Euler forces. This is a fact of physics, can be replicated in the lab. A stationary plane Earth with a giant rotating universe around it and an ether would show a translation of inertial forces down to the surface of the Earth that would be detected. It would be relative to how your latitude, effectively your position relative to the center of that rotation. If the center of that rotation is centered on the center of the Earth, then it would literally be completely correlative to latitude and even your angular positioning to that latitude, which is exactly what we see. It would be a dynamic equivalence. There is no way out of it. It isn't exclusive proof of anything.
Yeah, I guess I've heard it all before. I guess we can probably put it to bed then, because I don't. The thing that I've been missing from the start is the dynamic equivalence makes sense if you say, "Oh, I'm moving from here left," or "I'm moving from there right." Does it visually make any difference, and all of that kind of stuff? That again is relativity that I don't understand. But the physical moving, touching, feeling forces that I can feel, just get a bicycle and spin the wheel. You can feel what a gyro does. And the moment you've done that once, you can go, hey, if the Earth were turning, do you reckon you could use that for something? You immediately go, oh yeah, my guts, I feel how that could work. So
For sure.
while space-time may or may not bend and twist and shake and wiggle if you go fast enough, or your brother does something in space, none of that seems to relate. And I've tried to make that point really clear, and it seems that that's not going to land, so we can probably move on. But I just want to, for the final time, lay it to bed that people before relativity and after relativity were cool with these things because they seem like they should do. What about this? Why don't I finish on a question? Do you think if the Earth were rotating, a gyroscope must detect it?
Yeah.
You notice how
Yeah. So
nobody
that's it.
interrupted there? You went on for like a few minutes. Let's try that.
Really didn't.
Yeah. Well, what about the thing I pointed out? Is that important at all?
Which bit?
The not interrupting part of the context of the whole point of me saying that?
Yeah, I'm sorry. I'll try and not interrupt.
See, like a fundamental difference in you and I, right, is this is the same thing we were talking about with the sun in Antarctica. I cannot allow myself to stick my head in the sand and pretend I don't know a bunch of other things. Like one of the examples here is like when Dayton Miller replicated Michelson-Morley, he went to higher and higher altitudes. The higher he went, the more of a friendship he detected, the more motion he detected. The closer we get, and this was replicated even in like 2022, the closer we get to the sky, the more motion we detect. And in fact, the motion we detect, it correlates to what time of year it is. It literally correlates to solar motion. The minimum and maximum friend shifts that we detect is the spring and fall equinoxes, right? So like we have other evidence that shows we are detecting motion from the sky being translated to the earth. So the pendulum, when I look into the pendulum, it's super inconsistent, right? It's actually not very consistent. It seems like it's like the effect's a little bit smaller than what would be expected on a rotating globe, but there is still an effect, and that would make sense in this explanation as well. So like that's the part that you're not getting. You're like you're acting like you're just kind of boiling it down to first principles and being hyper simple and like straight to the point. And like unfortunately, the other beliefs that you hold, or even the main ones that you're invoking to explain how the gyro compass works, with everything else we know, you can't do that. You actually have to do this
What am
mental
I using to
gymnastics,
explain the
crazy,
gyrocompass?
chaotic thing. A tilted, wobbling, spinning globe that flies through space.
So it doesn't have to fly through space. It just needs to
It
spin.
does. No, but if it's spinning, it has to
Why
fly
does
through
the
space.
flying through space have to relate to
Because
how a
you can't even
gyrocompass
you
works?
can't explain the planets, the stars, the
The
precession,
question
any of
is,
that unless it's flying through.
how does it flying through space relate to how the gyrocompass works? That's the only
Because you
question I'm
can't
asking.
invoke the rotation unless it's flying through space.
So let me ask you this question. Imagine nothing else existed and an Earth rotated and a gyrocompass detected and aligned with that rotation, and nothing else existed. So it wasn't moving from anywhere to anywhere. There was fixed nothingness space around it, and it was just, for whatever reason, I'll also say fixed in place.
Yes, it would work.
Will that gyrocompass work exactly the same way it should on a spinning ball that is moving through
Yes.
space? Okay, so it
Yeah.
doesn't relate to how the gyrocompass works, that the Earth is flying through space. Thank you. It just relies on one
Oh,
thing, and that is the Earth rotating.
this is called the fallacy of division.
No,
Okay,
my
so this
argument
is
does
like
rely on the rotation. It doesn't rely on movement from A to B.
it's the fallacy of division. It's also just cherry picking. You're like, oh, I'm just invoking rotation. You can't do that. It doesn't matter how many times you say, yes, I can. No, you literally can't.
Why
It's
not?
the
So either
same
you're
burden.
arguing just to argue, or or you're going to actually try to
No, I'm
figure
saying
out
you
if
can't
this is
defeat this
actual
case
proof
about
of what you believe.
rotation, so you go to motion. You go to A to B motion. Because you can't deal with
No,
rotation, which is easy to detect, you go, hey, it's hard to detect this other thing. Why don't we spend our time talking about that? Which is fine if you bring it up. But when I bring up the gyrocompass and you go to this linear motion thing again and again and again, it just shows you know this is a good point, which is why you want
I'm
to get
not
away
going to
from it, why
linear
you want to
motion.
keep going to
I'm
linear
literally
motion. Oh, what about
I'm
Michelson-Morley?
invoking
What about
rotational
this
motion.
frame dragging, which
No,
is
you're not.
only relativistic, which doesn't
Oh my
relate to
god,
gyro?
frame dragging is rotational motion. Have you understand
Gyros
that
don't
yet?
frame drag.
Okay, so you were wrong. It isn't linear motion. It's all been about rotational
Do
motion. Okay,
gyros relate
now,
to frame
this
dragging?
is it, yes, it
I'm going to
absolutely
ask
would.
this of the AI.
Yes,
So,
yes, it absolutely
so
would.
what is frame dragging, and would it
Okay, well, if you
affect
ask your
the
retarded questions, you're going to get
function
retarded answers.
of a gyro compass? I
Okay,
think that's a
dude. Well, we don't need to hear you. We don't need to hear you say it out loud while you type it. This is the other thing. This is why people should inform themselves about the actual history of it, right? Because when you look at Michelson-Morley, that's about the orbital motion. Then you get to Michelson-Gale-Pearson, which is about the rotational motion, which is the very thing that you're invoking. And the Michelson-Morley
did
obviously
they
didn't match the predictions. Please stop interrupting me. It didn't match the predictions, but we're using the same exact principles, the same exact equations for Michelson-Gale-Pearson. It matched the predictions of the sidereal rotation within 98% accuracy. So well, wait, how's this? Wait, what's going on? And no one can figure it out because why are we detecting rotational motion, but we're not detecting orbital motion, but we're using the same principles of physics? So we can't pick and choose and say one can't be detected, one can. It's the same principle of physics, same equations. The
well,
obvious explanation
can I
there
ask
is
the
that there
question?
is only that the Earth isn't moving, the sky is moving, so there is one real rotational motion. It's the sky, and the Earth isn't moving. That explains all of these things.
Well, so that there's two questions. There's an important distinction, right? If Michelson, Gale, Pearson, I haven't scrolled down yet. I've asked about it, but I haven't read it yet. Michelson, Gale, Pearson are trying to detect the rotation of the Earth by detecting the linear component to that, right? Where if we're on the circumference of a circle, we go around that circle, and that is both a rotation, which is a torque, and it is a linear thing, and we could detect either. Then if they're trying to detect linear motion by assuming an ether, they are going to be wrong. If they shoot into the sunset and into the sunrise and they go, oh, we're trying to detect the difference between that, they're not detecting torque. And what we're talking about here is torque.
No, that's not what they did.
Okay, that's worth checking then.
Basically,
yes,
Michelson, Gale, Pearson. It's nothing. Michelson, Gale, Pearson has nothing to do with linear motion. It's just a giant gyro, basically. So it's like if you shoot a laser through something that's rotating and you shoot it in both directions, where they're going to come meet each other, the laser that's moving in the direction it's rotating is going to go faster. And so they just use this based on the sidereal rotation of the sky, which they attributed to the Earth rotation. They got a prediction, right, of what the difference should be between both lasers, and it matched the sidereal rotation within 98%. It's basically just a giant underground gyroscope.
Yeah.
So it's based specifically on rotational motion. It's not based on linear velocity of anything.
Yeah, okay. So it sounds like it did detect the rotation of Earth, though. So it sounds
well,
like
it did. Yeah, it did. That was my point. It matched it within 98% accuracy. So yeah, it sounds like just if you take that alone, you'd be like, dude, this proves the Earth's rotating. But when you compare that to Michelson, Gale, Pearson, which also uses the same exact thing, like the same exact principles of physics, the same exact equation, the velocity of light component, the medium differential, all the same equation, it doesn't detect it. So if it's detecting the rotation of Earth in Michelson, Gale, Pearson, it would necessarily have to detect the movement of Earth through space in Michelson, Morley, but it didn't. When you combine the two, there's only one viable explanation, which is that the Earth's not moving, but the sky is.
That sounds like you're saying they tried to detect linear motion using interferometry and they failed. Then they tried to detect torque with interferometry and they succeeded. But if they failed at one method, then the method they succeeded at must be fraudulent. Like, does it detect rotation?
When you invoke linear motion, you're invoking relativity. Do you understand when you invoke linear motion? Pause. Do you understand that when you invoke linear motion for Michelson Morley, you are invoking relativity? Do you understand?
Yeah, I mean, I think probably both. Once you're into the realm of light, which is why I talk about mechanical gyro, once you're in the realm of light, you're probably dealing with relativity either way. The idea that a light is bouncing, because look, I've got it on my screen, it looks like Michelson, Gale, Pearson just invented the first ring laser gyro, effectively, right? Is that it?
Kind of, yeah. I mean, if you want to say it, they didn't necessarily invent it, but yeah, kind of, right? I mean, then it's the Sagnac effect. When Sagnac discovered this before this, right? So the Sagnac effect was already discovered. He said it was based on the vortex of the ether. But yeah, basically in Michelson, Gale, Pearson is basically a giant gyroscope in like very simple terms. It's the same like mechanical system. But my point is, think about when you apply Newton. So you have the Earth moving around the sun. Newton would say the gravity of the sun is pulling the Earth in. So an object that is going in a straight path will continue in a straight path unless an outside force acts upon it. So the Earth would just continue straight, but the outside force of the sun's gravity acts on it, pulls it out of its straight path, and makes it rotate around the sun, which is by definition rotation. It's a circular motion around a central axis. So that cannot be invoked in Michelson Morley because we would absolutely be able to detect it. The way Einstein got out of it was to say, oh, well, it's rotating, but when you're on the Earth, it's like it's linear. It's both at the same time. Trust me, bro.
I don't understand.
So
it sounds like, we've got a problem with detecting linear motion, but when Michelson, the same guy who tried to detect linear motion, goes, oh, hang on, what about gyros? He found you agree he can detect with high accuracy.
You just did it again.
I don't understand.
You called it linear motion again.
He's not tracking. Dude,
why would you think it's linear motion if it's rotating? Yeah,
the
it goes
Earth's going around the sun in a circle, dude.
Right.
You understand that? And anything that's going around in a circle, that you're going to experience centrifugal forces, angular momentum. You should be able to pick it up. They're not picking it up.
Oh no, they do. Sorry, I beg your pardon. Like if that's the point, I put the thing in the
chat. No,
they
don't. No, they do. Dude, they do daily. Yeah, they pick up daily rotation of the Earth, right?
No.
Sidereal rotation. They don't dude, listen, just hear me out, because you're not. He's been trying to explain it to you for like half an hour. You're still not tracking. So maybe even in layman terms, you understand, right? You have proper acceleration and coordinate acceleration. Coordinate acceleration cannot be picked up at all. Doesn't matter how sensitive the instrument is. You're not going to pick it up because it's based on according to Einstein reference frame, right? So even though the Earth's supposed to be going around the sun in a circle, according to relativity, it's a linear motion. A geodesic is actually a straight path in the curvature of space-time. Now, space-time is actually, that's how you have to rationalize this between the proper and coordinate acceleration. That's what he's trying to explain to you. And you're saying, no, we can pick it up. No, you can't pick it up, dude. You cannot pick it up.
Yeah, so
that's why you have to
again, we're getting it. We might be talking cross purposes. I'm saying linear, problematic, difficult because we've got nothing to compare it to. Rotational, we can, and exactly as you were just saying, there is a rotational component to orbital motion, and that's why I posted a thing at 51 minutes.
But how are you calling Earth's orbit?
Dude, you're not listening, bro. You're like, dude, you're like a parrot, dude.
Oh my god.
We're not denying that you can. No, dude, we're not denying that you can pick up the daily rotation, right? You think
not listening. It's not daily. Listen. Let me get to the next.
The orbital rotation.
Orbital rotation. Yes.
Right, that's what I'm talking about. I'm trying to use like layman terms, bro.
That was the next word.
Daily 24-hour rotation of the Earth.
He's trying to make some claim. Time out. He's trying to make some claim that you can detect orbital motion, which is going to refute relativity. So go ahead.
So sure. So if what you're trying to detect out of orbital motion is the rotational component, some people, what was it, about 3-4 years ago? I've put it in the chat, 51 minutes past the hour, if you like the science. And they made a really massive underground ring laser gyro, and they made a really beautiful 6-month graph. So they got 6 months of what looks like a sort of monthly pulse, as well as a full arc curve. So they have now been able to detect a small diurnal, a larger, what might be monthly or moon path or something, and a larger half-year arc. So they have detected the rotational component of our orbital path. You're not listening.
Okay, so you understand the okay? Let me respond to that. You brought up the moon's path, dude. Bro, if what you're saying is true, then relativity is debunked, Brainiac. You don't even understand the implications of what you're saying. Now, if we're only talking about the daily rotation, that's not a problem, right? Because you're actually picking up proper acceleration, real forces that are being transferred to the instrument, right? You can actually pick that up. Now, we're saying it's not the Earth actually spinning, it's the sky spinning. That's what you're picking up, that you think it's evidence for daily rotation. Now, if you're saying that you're picking up, right, the revolution of the Earth around the sun with an instrument, then relativity is debunked.
So the thing that you're right about is if they were detecting the linear component, relativity would be debunked because they would be detecting linear movement relative nothing. But this, again, I want to make clear, is still torque. They're still just detecting torque, but now because it is 180 degrees over 6 months, it is an extraordinarily small torque. So they need an incredibly precise ring laser gyro to detect it. So they built it underground in Germany, I think, in a Faraday cage.
All right, let me respond again, dude. I know
and it is not. I want to make super clear: it is not violating relativity.
Okay, hear me out, dude. You're being incoherent, dude. You're being incoherent. I know that you don't. Even though you've been in here for years arguing this, you're like a noob, dude. And we're trying to explain something to you that even like Zanuck, Kosho, they would all agree. You're like in left field, dude, all by yourself. Dude, relativity invokes geodesic. When the Earth is moving around the sun, right, during the 365-day year, right, it's experiencing a straight line path. It's 0 G's, dude. There are no forces acting upon it. If you're saying that you're picking up a force, rotational force, a torque, dude, then geodesics go out the window. Then 0 G's goes out the window. Doesn't matter how nominal, doesn't matter how insignificant or nominal it is, right? The point of the whole thing is that relativity try to fix this dilemma, right?
Geodesics has nothing to do with the rotation of the body. Geodesics effects of rotating and non-rotating body the same, and the geodesics don't affect this measurement at all.
That's how you're able to call it linear.
Oh,
not
brother, are
talking
you
about-
not understanding what he's saying, dude?
It
He's
just doesn't
saying you're
affect it.
claiming that they're making these measurements all throughout the year, that there's a slight deviation, the precession basically throughout the year, and it's detecting the rotational component of our orbit. The problem is that according to the mainstream model, there is literally zero. It is completely impossible to ever in any way detect any component of rotation in our orbit if you're on the Earth. Because while you're on the Earth, that is what relativity says. While you're on the Earth, we are free falling in a linear path. The only way that you're able to detect any rotational component would be from the reference frame of the sun. That is the official model.
Yeah. So let's do it with a reference frame of the sun. I might be able to solve this for you. Would you agree that because our equator and our equatorial, sorry, our sort of star equator, sun equator, are roughly the same, that when you do a whole revolution around the sun, if you did 365 days during that, you've also done pretty much a whole nother rotation, because if you spun something 365 times while also taking it in a circle, it's actually done 366 rotations, because you did one. It's the same rotation is what I'm saying. So you're just going from 365 to 366. Get what I'm saying? So it's one rotation of one object. What geodesics describes is that it is falling in what feels like free fall. There is no net force or anything being put into that system, pushing the center of that mass out of that in any direction. But that is ignorant to, or just doesn't have any interest in, the rotation of the mass itself, right? The forces within the mass itself all behave as one point in geodesics. So all we're saying we're doing is they went from being able to very precise that they could detect diurnal rotation to pretty precise to very, very precise. And now they're getting so precise that over the course of half of a year, like I put it in the chat, it's just a picture. You can immediately get it with your guts.
Are they using interferometry?
You're not listening. The thing is, we're granting you daily rotation of the Earth, that you're picking up actual forces,
just
right?
plus one.
And you're conflating those forces with the revolution.
What do you mean? What revolution? They are would you agree that the diurnal
revolution of the Earth around the sun during the year?
Right.
There's two
Are they
different.
both a
have a different
revolution?
phase shift at different seasons. It's not even anything.
Are they both a revolution?
When Witsit earlier brought up, right, the equinoxes and how Dayton Miller was picking up deviations, right? And you can pick these up with the gyroscope, the laser gyro. You can pick up these deviations during the year, dude. We know that. And you're using that as like exclusive evidence for Earth in motion, bro. And we're like, nah, dude, like this is not evidence for Earth in motion. And then when you invoke the revolution, there's absolutely no evidence at all, zip nada, that you can pick up at all. Like you can't pick up any actual forces being applied to the Earth.
Except with a gyrocompass and a sufficiently precise set of scales and your eyeballs and a head devoid of Bibles.
Okay, can I make the comment I was trying to make?
It's the easiest thing to detect.
Yeah, before you scattergun, and I was just gonna say the ring laser gyroscopes, the equator, the north-seeking function is 0 at the equator and 15 degrees at the poles. So I was getting the ring laser gyroscope confused with the mechanical gyrocompass, which is 0 at the poles. But the pendulums are 0 at the equator, and the ring laser gyroscope, the ring horizontal sensitive axis is 0 at the equator. There's a horizontal and a vertical component, which can make it a little bit confusing. And the vertical component of the gyrocompass is 0 degrees torque at the equator.
Say again. Say the last bit, just the last sentence again, please.
The vertical component of the mechanical gyrocompass is 0 at the equator.
Sure. Yeah, it's perfect. It's in its most perfect position or something. Yeah, sure. But it does work at the equator. You're now accepting. It sounds like you've gone from.
Yeah, I think I got it. I was getting it confused with the pendulums or the ring laser gyrocompasses. Because remember, pendulums have 0 precession at the equator, which is kind of the opposite of the north-seeking function of the gyrocompass at the equator.
Yeah, I don't fully
I know
get. I
that
must admit, I
Alan
don't
is.
fully get the Foucault's pendulum. I get that there should be some spooky force, but it doesn't really make sense. And when I read into them, they don't work very well. Where I think you're wrong about a ring laser gyro. I think a ring laser gyro, particularly if you got one of those 3-axis ones, would detect the rotation of the Earth anywhere, such that if you told it what horizontal was, it could tell you your latitude. It would be able to tell you if you were standing on the North Pole or not.
Well, Eggs, why would there be like anomalies during an eclipse or during, equinox
I don't know,
solstices?
but
Why, if it's a constant rotation and what you're picking up is a constant rotation of the Earth, then how come you picking? Why is these
so
anomalies
that's a
manifesting?
poorly replicated result. That's an interesting question, but it's a poorly replicated result. And one of the interesting theories that I had that actually turned out to be a theory other people had is it was right at the eclipse in the astrology or physics department of a university that was made of wood. And it's like, well, no wonder your pendulum did something funny when everybody went to look at the eclipse, which I don't know if I believe in, but I don't know. Maybe it affects it, maybe it doesn't. But are we on a turning body? Or yeah, absolutely. That's something you can tell for a quite high degree of confidence.
So wait, okay. Look, this paper's based on a 432-day oscillation. So the 6 month is it's an arc and within that 432-day oscillation. It isn't based on the orbit. So this is not even claiming to do that.
What happens over 432 days? 432 days is how many of 365?
Is how many
Half.
of it?
It's half of it. That's why I said they've done half of the year. The easiest is just that spirograph diagram, which shows it starts in June 2002 and ends in Jan 2002. Sorry, the other way around.
The heavens do shift in these seasons. But I want to see, I'm checking. Oh, the Y. See how there's an X and Y component?
Yep.
This kind of reminds me of the analemma.
Yeah, it should do. It should produce exactly the same data in a different form, I would guess.
It should be doing a figure 8.
No, it should be doing a circle, but it's
The analemma is a problem for them, actually.
The X and Y is based. This is based on a specific position on Earth, and it's using like Earth's crust as the reference. And it's got a specific place that they use in Italy that are like just used by geodesists or whatever. It's called the conventional international origin. Yeah. So then it takes it's a big circle based on the Chandler wobble, a 432-day oscillation that they claim is obviously relative to the axial spin. So it's based on that alone. It's a 432-day cycle. The 6 months is where you get it's based on being an arc of the 432 days. It's in relation to the Earth's crust.
Sure.
And the Chandler wobble of the Earth.
Yeah. So when you bolt something into a mountain in Italy, it detects a series of wobbles. The most precise rotation detecting device is, and if you look at it, it's like you can see the big loops, the small loops for days, and then the longer loops that look like they must be sort of a week or something, 2 weeks maybe, and then a bigger arc that makes up 6 months. I could tell how long it is back. 1, 2, 3, 4.
I just posted a picture. It kind of summarizes for the horizontal, normally mounted ring laser gyroscope. It's 0 at the equators and maximum at the poles, opposite of the gyrocompass.
What is the horizontal? Yeah, horizontal is going to be 0, but you're just looking at the horizontal
component. That's what finds north, though, on the gyrocompass.
It's just, I mean, I feel like you keep looking for where things aren't going to be.
I'm going to do the contrast.
It will be in the vertical. Check the vertical.
See how they're opposite?
Sure, but check the vertical. Will you detect it with
So I'm trying
to
your claim has changed to it's detecting the wobbles of Earth. It's not detecting the orbital motion.
So what I'm saying is it's detecting the rotation of the Earth that is necessitated by it going around the sun, particularly because it's rotating in the same way that it's orbiting. So it's just adding another day in.
That's so
right?
problematic. And so
if it's finding days, it's finding another day. That's all. But it's just
it's
getting
talked about
accruing that day over a year.
It's the axis of rotation. So it's not even talking about the revolution. Now you can say it's connected, contingent to the revolution.
Yeah,
it's a separate argument, but even then that would debunk relativity. But you have to understand relativity. And when we talk about these natural phenomena that manifest on Earth, whether it's Foucault's pendulum, laser gyros, right? Like we're not even denying that you're picking up an effect like a natural phenomenon. What we're arguing is the cause of that effect. You're saying it can only be this, the Earth in motion, right? If P, then Q, Q therefore P. That's classic begging the question fallacy.
I didn't do that.
We're providing,
you had to do that whole thing.
We're providing other possibilities that are more reasonable, especially when you start to consider not just the axis of rotation, but also the revolution, dude. Because it should be the same forces, but yet you're missing any actual forces with the revolution. So that's why Einstein had to come in and save the day with relativity, dude, and invoke reference frames and inertial pseudo fictitious forces.
No, not for the rotation. I don't know how many times to say this. Rotation is just you can deal with just with Newton. It is the linear component that until you get to something that is rotating so fast that people are moving at relativistic speeds on the surface.
Earth is said to be rotating around
You have to use arbitrary constants even for the gyrocompass, and you cannot directly apply Newton's laws of motion to make the gyrocompass equations work.
The only reason you can call the orbit linear is because of relativity.
Do you want me to cite it again?
Yeah,
I've read this out to you multiple times.
I'm gonna back out. Let me just say this last thing.
I'll read it right now. I'll cite it again.
Tayler, you can
it's a lot of information. Just give him a chance. Sounds
Let me just say this last thing.
He's acknowledged the issue. Go ahead, Len.
Last statement. I'm gonna back out. You guys can have it. Have at it. I just want to say this last thing. Okay, real quick. So this is the problem, Eggs. We're dealing with two different types of motion, right? With the NLMA, Tayler brought up the NLMA earlier, right? The NLMA requires, right, an elliptical orbit around the sun, right? Kepler figured this out, right? Going back to Kepler, came up with the 3 laws of orbital mechanics. You need an asymmetrical orbit, an eccentric orbit, and I forget the other one. I think it's an eccentric orbit and an elliptical orbit, right? That's why you get obliquity. Now, with that, you need the Earth during its revolution. It needs to change velocity, dude. Right? So you have a change in velocity, which means what? Acceleration.
Debunked the globe. Yeah, we're accelerating and decelerating with no energy going into the system.
Yeah, not only do you have... Yeah, right. So during its revolution, as it's making its... between the perihelion and epihelion, right? As it's making its way towards the sun, there's a 3 million mile differential. During that 3 million mile differential, between the 6 months, you're going to have an acceleration, a positive acceleration and a negative acceleration. That you should be able to pick that up, even according to Newton standards. You should be able to pick that up with an accelerometer.
Is that linear?
Right? Even linear motion when you're experiencing acceleration.
Oh, I see. You should be able to pick that up with the accelerometer.
Yeah, to be
fair, I agree with you on that one. It doesn't. I get it now that I've played Kerbal Space Program, because it's all free fall. But I get you on that one where we are speeding up and slowing down by moving now. An accelerometer should get that.
Let me just finish. I'm almost done. I'm just going to finish right here. I'm linear here, right? So not only should you be able to pick up acceleration, even if it's very insignificant, nominal, right? You should be able to pick it up. You cannot pick it up. Not only can you not pick up a change in velocity, i.e. acceleration, you can't pick up angular momentum. You can't pick up the rotational acceleration that all objects that are rotating are experiencing centrifugal forces. You can't pick up either, dude. None. Zip. Nada. That's a big problem for you guys.
So it's difficult to detect. It's difficult to detect a certain kind of motion is something that I've been agreeing to since the start of this, like 2 hours ago. It's difficult to detect linear motion. It's mysterious how we are speeding up and slowing down in our orbit when there's no energy going into the system and that we don't detect that with accelerometers. That's exactly right. It's difficult to detect. But if the Earth's rotating, we're orbiting, and if the Earth's orbiting, we're rotating. So why would you not look for the place you will find a meaningful answer, which is the one I've put in front of you? The Earth is turning and good evidence shows it. And when I bring that up, instead of discussing that, we endlessly must discuss relativity. And I want to repeat this, and then I can hand the mic on. a theory you guys reject and I don't invoke, you use to rebut whether a spinning mass can detect an axis, right? A theory you disagree with is used to debunk my theory. You say, no, you've got to agree with this. And I say, well, it doesn't appear in my argument.
I lied.
Like,
Let me
it's
just say one
relied
last thing, dude.
upon.
Let me just say one last
It's not. I don't
thing.
rely. Show where it
This
fits
is
into
the
my
last thing.
argument.
Dude,
This is
I
Really
know
theory
that
of
you keep
post-relativity.
saying you keep saying that picking up linear motion is difficult. Yes, it's difficult if it's at a constant rate or at a constant velocity. With the Earth, we're not talking about a constant velocity, dude. There's a change in velocity,
Yeah, I agree.
i.e.,
There's an
acceleration.
acceleration that is
Now,
hard
just
to
like a car, dude.
Yeah.
Just like a car, right? If you can actually feel the change in velocity. You should be able to pick that up. It's not difficult to pick that up. Go ahead.
But would you use a gyro to detect that? How would you detect it? It's very hard to detect. I agree. You should detect it. It feels to me in my gut like that should happen. If I speed up by 3 million miles an hour, I should feel that. What would you use to detect that?
What, linear
I'll let
motion?
somebody else talk, dude. I'm good. I got to get back to work.
I mean, you can
According to you guys, you
use.
can't. But wait, real fast. Do you understand where this extra day is coming from? Do you understand that it's the difference in the sidereal and solar day? And it's 4 minutes a day over the course of a year. It effectively gives you an extra day. That's where the extra day comes from.
Yeah, that's the way it makes sense in my head. It could well be wrong or something, but we're definitely rotating in the same way we're orbiting. So, yeah, to me, it equates to 364 days plus our rotation.
Well, it's just a definition of sidereal and solar day. They're different. Solar day is exactly 24 hours. Sidereal is like 23 hours, 56 minutes, however many seconds. So that's 4 minutes a day. Over the course of a year, you get an extra day, which is, it's just definitional.
I tagged you in the
That's
thing
not
the other
inclusive.
day. Eggshells that I've sent multiple times. I'm sending again.
Where?
With the link about how Newton's laws of motion cannot be applied to the gyrocompass calculations, and they do not because you have to invoke scalar quantity, and they have arbitrary constants that are added.
Did they say you can't apply it or difficulties be using scalars and they still use?
Yeah, it doesn't work. If you find anybody who has tried to apply them, I'd be open to see it. But there's
what about
issues?
Did they? Detecting, what is this about? Newton's laws of motion regarding the gyrocompass or the gyroscope?
The gyrocompass, yeah.
Yeah.
I mean, just to make sure everyone understands that, obviously, like the difference in sidereal and solar days are obviously not exclusive to any model, right? Like heliocentric or geocentric. You just would have in the heliocentric model, you have the Earth spinning on its axis and also moving around in its orbit. So it has to rotate a little extra each day to bring the sun back to the same point in the sky after a year. And when you measure them against each other, obviously you end up getting an extra day. But in like a geocentric version, you have like say the celestial sphere rotating around a stationary Earth, and the sun's position drifts among the stars by about 1 degree per day along the ecliptic, right? And so then the sun takes a little longer than the stars to return to the same spot. So it's actually more complicated in a heliocentric model.
Sure. Yeah. It's like but it all fits together, right? That's where we were a while ago. That all of the solutions for flat Earth are about explaining why it looks so much like we're on a spinning ball.
No, that's the opposite of this. This looks so much like a stationary Earth where the sun moves independent of the stars that the heliocentric model had to add a bunch of wobbles in to try to explain it. If you actually look at the paper, that's just modeled out. There is no measurement invoked at all. They just modeled that out. The 23.934 whatever it is hours, like that's just the standard model. Like we just know the sidereal rate. So like from a stationary Earth, we would expect the sun and stars to move slightly different. They're different things. But in your paradigm, like they shouldn't. But you guys invoke the orbit and then wobbles to explain the discrepancies. And then you have to invoke other wobbles, right? Because you get the precessions. So then you start I've never seen anyone be able to physically replicate what they claim the Earth does, where you have like 3 or 4, I think it's 4 different wobbles. It's supposedly spinning, revolving, being carried through space, and then wobbling 4 different ways simultaneously.
Sure.
So I mean, it's like I think it's the opposite. I think it's like you're trying to back engineer and backfill a moving Earth with observations of a moving sky with a stationary Earth.
Except we can do it with gyros under mountains, right? Things that can't see the sky, don't know what the sky is doing, and spinning masses can say, oh, that's the direction south. Due south is that right there.
You don't know. They always know what the sky is doing. If there's a medium that's permeating through our reality,
it's a medium that is not a particle, behaves like a particle, but only if you're trying to detect the rotation of Earth. It's not a. It could be electro. What is your one? Witsit? Say it again. Electro.
kind of like the quantum field.
Magnetic or electrodynamic.
Now we're back to where's your gravity particle? Where's your gravitron?
Understand what that means? I don't invoke it. I only argue for things I invoke, and I only ask other people to defend.
Well, you're setting the standard for validity at it. Is there a particle? Like, is this ether a particle? Right. But you guys also have gravity, which
does it have mass?
You don't have a particle for.
It doesn't have
Does
mass.
It have
no.
Like, okay, so no. A massless
quantum
thing.
has already proven that it's a thing, bro. It's a medium that permeates all of space, and all of modern quantum has conceded it. So.
And it has no mass. Okay, so it is a thing without mass, but it can affect a spinning mass.
How much gravity? How much mass does gravity have?
We're not talking about gravity at the moment. You guys are so
I'm
desperate
showing
to
the parallels between.
How could you measure the mass of a medium that permeates all of space? Like even if it had mass, how could you measure?
It's got no mass. But my question is, how does it affect
no measurable mass?
Right, so it's got no measurable mass. So how does it affect the rotation of a gyroscope that does have mass and hence inertia? The whole point of a gyroscope is to increase inertia, right?
Because it has actual properties of physicality, right? Like
properties of physicality.
It's just
not physical itself.
Well, it could be so tenuous. It could be so tenuous that we can't detect it, which is what Tesla said. Or beyond that, the assumption that it's comprised of constituent little parts. If you actually look into what mass is and how it's supposedly measured, you're actually going to have to get a charge. So, like, if you're not actually able to detect a charge, you're not getting any mass. You have a charge to mass ratio. Well, like with the medium that permeates all of space, you don't actually detect that, right? Or like with the vacuum chamber, we see like random excitations within that background. But the medium itself, it's like it's not something that you can grab and measure. But that doesn't. We see that in a vacuum there is resistance of free space. So we see that there is something resisting in free space. It's called the impedance of free space, and it's 377 ohms. And this is what all of like physics is built off, right? So we know that an empty vacuum chamber does still have resistance and impedance. So, which is slightly different than resistance, right? Slight distinction.
Well, it also no. Don't forget, like, I feel like that's a good point. That's a point people don't talk about, but you can still shoot light through the damn thing. How does light operate in a vacuum? And how come my eyeballs don't have, photon sacks or something? Like, we need to start really questioning, the canvas of what things operate on. Otherwise, we're just missing the point.
It's because there's an undetectable conceptual field there, Riggs.
That's mathematical, but actual. Yeah.
Right.
Oh yeah. Light, and isn't it interesting that the light's not visible though in the vacuum?
A tree grows 2 directions.
So far from a gyroscope, though. Spinning masses don't
light
need light.
is invisible in a vacuum.
And that's the thing. If it's got no mass, if it's got no mass and affects light, I get it for the answer for the ring laser gyroscope. For Bob Nodell's, it's fine. But for a dark, massive
gravitational fields don't have any mass and they affect physical objects, even in your paradigm. You don't see the parallels.
And then
that's fine. It affects everything, not just light.
But then you say it is this thing that affects it in this way, right? It passes into a magnetic field, and as that magnetic field gets stronger, it applies an acceleration or something, right? And then you go, great.
No, just inertial forces. Inertial forces are translated through that medium. You were then questioning the medium if it's not got mass, whatever I'm explaining to you. Well, we know there's impedance of free space. There's a medium there that translates motion. It's not arguable at this point. We've proven it.
That's what's in
It's
question.
quantum. You were
That's what's in
questioning it,
question.
saying
What
if
do
it
you
doesn't
mean?
have mass, how could there is nothing to question? It's just a fact. Like there's
But
an
we don't
impedance
question
of
it.
free
We
space.
don't prove our
You can question
case.
it,
We
but I'm
just
giving you
assume it's
the
already
answer.
true.
No. There is provably impedance of free
Prove it
space.
now.
So in proven how? Okay. Like
No,
for
I said prove it
example,
now. You're just saying, I assure you I've done the homework, sir.
no, I'm
Show us
saying, yeah, are
now
you
why this
disputing the
impedance of free
impedance of
space
free
affects the
space?
gyro.
Yeah, it's not
Okay, no,
even
the
in
point is that
controversy. It's
no,
agreed upon
yeah,
mainstream. Like,
it's just establishing that there's a
Again,
medium there.
nobody. Do you notice how you're just not making arguments? You're just assuring me
You are
somebody
just
else
not
has somewhere done
following
an
the
argument.
argument. You're not following the
What is it?
argument. So we've
There's this
now
It does.
thing
It
established
that I
does
there's a
seem
can't
like
tell
you're
you
not
about.
tracking
listen,
eggs.
we've now established there's a medium there. There are inertial forces generated by a rotating universe. It would translate through that medium down to any physical object, including a gyrocompass.
So I don't think there's a medium, but if you do, I'm just inviting you to say through what kind of thing. Like it sounds like you're saying it's a little bit like particle collisions, but they aren't particles that take up space in X and Y. So they have no volume and they also have no mass. So and I'm just saying I need a bit more information there. This sounds deeply mysterious. And you're like, I assure you this is already, come on, how can you not already get this? It's deeply
Okay, yeah,
mysterious.
It's a quantum
it's
field.
again, there's an impedance
Quantum
of free
field.
space. They call it a quantum field typically. You know,
Okay.
they claim that it permeates all of space. You have the Higgs boson field as well, right? It's well known
Yeah.
that it is perplexing. It's
Yes,
perplexing
it is a
to
bit.
the mind, but like that's what quantum is effectively. But like what we find out is when we have a vacuum chamber, randomly energy pops in and out of there, and that whenever we shoot something through it, there's something impeding it, even though there's not supposed to be anything in there. And we consistently measure this. And so there's this primary background that permeates all of space, and then all of this physical phenomena, electrons, protons, photons, they come from there. And so what modern quantum claims is that it's a quantum field, the localized excitations of the electron field or whatever is the electron. And they all overlap to create this all permeating field, etc. But there's a huge branch of quantum that's basically moving over towards a superfluid vacuum and different types of explanations of like recognizing the fluid background medium. So there are different explanations or definitions of what that background medium is, but we've proven it exists. That's what I'm saying. We've proven it exists because something's
Is
impeding.
it?
Nothing can impede something.
Can I read this?
Go
Physical
ahead.
states of the quantum field genuinely behave like as a media. A plasma, so this is examples of how it behaves like a media, the quantum field. Okay, a plasma supplies a preferred rest frame and changes light propagation. A superfluid or Bose-Einstein condensate supports collective wave and has material properties. And lastly, the Higgs field has a non-zero vacuum expectation value, but that does not provide an ordinary drag-producing medium or preferred inertial frame. So for the
I don't
Higgs
know what
field,
that means.
so
Can
they do
somebody?
say that the quantum field is a superfluid or Einstein condensate.
It sounds like rather than
Wait,
discussing gyros, we are now dreaming up really esoteric, imaginative
this is
ideas about.
mainstream.
But do you notice
No.
how you keep presenting to me, your side keeps presenting to us things you don't believe in that we aren't invoking.
They're just calling it a different name now.
What
It's
we do
But
believe in
isn't that
this, yeah,
important?
we do believe in this. We
Look,
call it ether. They just call it a bunch of different other names because they can acknowledge the ether,
Right.
and that's their problem. That's not our problem.
Sure, but we could just discuss the ether, and it sounds like it's quite difficult to. So it's imparting forces on a spinning mass, but it's massless and has no volume itself. Do you have an idea the mechanism by which it turns? Because an easy way to move a mass is with a particle collision, imparting ordinary Newtonian forces, right? Another way to do it could be with a magnetic field.
bro, you're looping again.
But
Well, no, even just
magnetic
invoking
fields
the
don't.
idea of
I'm just.
gravitation. Invoke the idea of
Am I?
gravitation, right? No, I'm saying even if you
Well,
do, well, your paradigm invokes gravitation for the gyro. Yes, you can't you can't explain a gyro compass without gravity. So, like,
sure, it's got a
my
vector
point
of
is,
down. Goes one way.
okay,
Yeah,
but the point is, a
I
vector of
can
down is
explain
the
it.
effect of gravity. So
Sure.
gravity it acts to immense distances in a vacuum. There are no particles exchanged. It's still a real physical interaction over the vastness of space. So, like the electrodynamic force of Weber's equations in relational mechanics, for example, it's equivalent. Gives you the exact same effect, but it would be a real effect. So it doesn't matter. The point is, you can't pick and choose. So, like the very like critique you have would refute your own causal mechanism, right? Like,
well, no, because I've got a causal mechanism that gives you a vector. You have ether, which is in itself mysterious and has no vector. In fact, it's got a
no,
rotational
you don't have a
component.
causal
So
mechanism because you
it's
said
not
it needs to have
like
particles.
gravity, because I could just say it's probably something to do with mass, and you go, what makes you think that? And you point down the vector, and you go, that's where I think all the mass coalesces. So you've got a workable theory that doesn't understand how the mass affects the vector, but it just says I can make a prediction about where that vector is going to point, and it's going to point at the middle point between the most massive thing nearby, right? By a blah 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 of the square field, whatever theory, right?
So your own critique would
So your one has no vector. It has no explanatory power. It goes, oh, mysterious shit's going to happen that makes it look like we're on a spinning Earth, and it's going to happen only in the vector of us checking it right now. But it's not got any explanatory power as to why it does that thing, right? It doesn't. It is massless and yet interacts with light, which makes sense. You know, massless interacting with light, I think, is a pretty strong
You're claiming the same thing.
But
I know we've been telling them. We've been telling you the whole time, though, Eggs. You're acting like we're not making the point or something.
Yeah, you're not. You're honestly
But both sides have the same burden.
Nope. Your side is ruined on this, and you can't address it. So you
Oh
keep
my God, you claim gravity affects light, buddy. You claim gravity affects light, and that it's massless, and that there's no particles, and that it interacts in the fastness of a vacuum.
Eggs, you're just wrong there, man.
If I may,
gyrocompasses.
If I may, a tree grows two directions, right? A tree goes to the light, and it also grows gravitropic, which means grows in the dark too. It's two different directions that it grows. So there you go. And the medium is its surface of the earth there. So that's your gradient there, and that's a real thing.
Yeah, I mean, there's all kinds of stuff that's shown us there's a medium, brother. You should research it. You have 0-point energy, Casimir effect, the Higgs field, quantum foam, quote unquote. You have vacuum bifringence, and you have the Lamb shift. I could probably list like 10 more if I sit here and think about it.
Omnivore was on your side on this.
I'm going to make a bet now. None of those four you mentioned, I'll bet you $40. None of those you mentioned would intersect with the functioning of a mechanical gyrocompass in such a way that it wasn't detecting Earth's rotation. No sensible physicist would write a theory that would doubt that.
No, okay, the medium, because that's not what it's a straw man. You're betting $50 on a straw man. You don't even understand it still. All those things do is establish that there's a medium there. So your weird critiques of it being massless or you don't understand it, we don't care. Your appeal to incredulity is dismissed as such. Okay? We've established the physical empirical evidence that there's a medium there. If you don't understand it, I'm sorry. If you're unfamiliar with it, I'm sorry. If you don't know that the evidence is undeniable, I'm sorry. So there's a medium there. I gave you the definition of a whirlpool. You're like, oh, I get an analogy of the whirlpool. You're like, well, those are physical particles. Okay, again, you're just talking about how you don't understand what's been proven in quantum mechanics. That isn't our fault or problem, bro. It literally doesn't mean anything. It doesn't.
There could be a medium that doesn't affect it. There could be a medium that doesn't, just moves through it, and it doesn't, which is what most people thought ether was, right? They thought it didn't affect gyro. This is why I keep making it up. When they started with gyrocompasses,
they thought it was static.
They thought the ether was there, right? So they still thought gyrocompasses worked when they thought ether was there.
Static
because they
ether.
Thought it was non-reactive. The Earth passed through it without noticing about it. So that theory that there is a medium doesn't mean that medium is going to tilt a gyrocompass. That's the question. You need the mechanism that links it, not saying, I swear there's a field.
Okay, check it out.
Saying, how does the field interact with physical reality?
Well, check it out. So now we have real physical objects in space. Okay, those are real physical objects. They're all within this medium that's connecting everything. We have a real physical object. In whoever's paradigm it is, there's obviously something physical going on. Giant galaxies, planets, whatever. These things are all rotating around the Earth. A giant mass, effectively. If you look at the universe as a giant mass, it's rotating around the Earth. That real physical mass is generating a real physical inertial force. That real force in real physical reality is being translated down. They're inertial forces. So you have a Coriolis force, a centrifugal force. Those are the two main ones, right? If the universe is rotating around us, that would generate a Coriolis and centrifugal force. Not like the Coriolis in the globe, where it's just an optical apparent effect. Not like the centrifugal force in the globe model, where it's just a fictitious. It would be an actual, real inertial force, right?
And
It
how would
wouldn't be
it? How would
pseudo
it?
or fictitious.
Okay, but so if there's a pseudo force, it's kind of tough to say where the force is coming from, but you could say the rotation of something. Or otherwise, you could say, where's that force coming from? It's coming from wind or the compression of pistons and tires turning. And we get an idea.
A rotating universe.
The rotating universe is imparting force, torque onto a spinning mass. And the question is just how.
Let me answer.
Yeah. Hold on. Yeah, Taylor, you had something? Go ahead.
Yes. Okay. So there's a paper where they had like this levitating gyrocompass, and essentially it was like it had no torque. And so it was like rotating at a high speed to where it actually produced its own magnetic field, and this is called the Burnett effect. And high rotate anything, whether it's conductive or not, that rotates fast enough can generate its own internal magnetic field. And so it was actually processing off of the magnetic field that was applied to the area, and it had a precession that was processing off of it because it generated its own magnetic field by rotating at such speeds. And to get a gyrocompass to even work, you have to get it rotating super quick.
Yeah,
and
I agree to both of those points. Yeah.
Process.
Gyrocompasses work by detecting the rotation of Earth by spinning really quick, and that will make a magnetic force. So you could say that it has to create a magnetic force in order to detect the rotation of Earth. I can agree to all of that. Yeah.
So they actually got
You should be super excited that Alan's about to do a full presentation.
This could be the Burnett effect. Just something to throw out there.
The Burnett effect?
It generates an internal magnetic field that kind of repel off the magnetic field, which even Faraday cages cannot stop the magnetic field of the Earth. So you can have this inherent precession occurring.
But it doesn't find magnetic north, so it's not really confounded
None of
much
them
by
do without
magnetic
having
field.
damping applied.
It just doesn't sound like you're really engaging with the topic.
What do you mean? I'm
Hey,
engaged.
she's explaining
None of them find north. They
that
just keep
it
spinning.
uses damping to find the north.
But we were
regardless.
just talking about magnetism, and you're like, I want to talk about the damping now, which we've already killed. That's like a zombie argument.
No, it's because you invoked finding true north.
You invoked some other mechanism that could be working. I gave you one, and you said, "Oh, well, it can't find true north." Well, in this sense, I would propose a mechanism where if it's processing off of the magnetic field that's applied, it could interact with the magnetic field of the Earth or some other field, that we don't. We have fields that we don't fully understand. So we know that it can process off of magnetic fields, and we've actually seen it occur. We've seen a gyrocompass. We've rotated it. We've introduced the magnetic field, and we've seen precession happen. Because it's called the Burnett effect. It has its own. So that's a mechanism. And then you said, "Oh, it can't find true north." I want you to understand that the gyrocompasses that are used, the mechanical gyrocompass, cannot find true north either unless you apply damping. It's going to just keep spinning in a circle.
But hang on, can a mechanical gyrocompass find north?
Like if you were to just build it without any external corrections or damping?
I'm going to say, are you going to sell a thing that has compass in its name if it can't find north?
You have to pre-calibrate it though.
External correction mechanisms for it to even do that. You act like it's just some inherent thing anybody can build. It's fundamental. No. You have to apply damping and latitude corrections.
Yeah, it works.
Well, I mean, you guys are one yourself, right? You stand on your feet and you have your head, and your head's pointed zenith. So, I mean, there you go. There, argument over.
Yeah, like actually, you are presenting it as though because the Earth is a spinning globe, we can just take this really archaic physical object, walk outside, and then the fact we're rotating is going to make it go north. That isn't actually true, though, right?
Yeah, you have to apply damping.
I will bet that absolutely that is how it works.
No, it's not. You have to apply damping.
$100.
Look it up. Look up what's going to happen with the gyrocompass without applying external damping. What's going to happen?
What do you mean when you say external damping? Do you mean if you get a working gyrocompass and then take some part out of it that you call damping?
No, building it from the bottom up.
Are you confusing? Are you confusing the damping with the ballasting?
No, just found a way that it works and says if we take out one of its main functions, would it still find north? Where the question is, if it's magnetic, Tayler, why does it not find magnetic north? It doesn't know where magnetic north is. It knows where true north is. So the magnetic argument is ridiculous. Yes, it uses damping in order to minimize wibble in the precession because it'll want to waggle quite
Damping is
violently. And if you have damping for that, it'll find north quicker. So the original ones took a while to find north, and then with damping, they find north a lot quicker.
No, it would never find north. It would keep spinning in a circle. It doesn't stop.
No, it doesn't.
No.
Yes,
That's
it
the charm of the gyro compass. The charm of the gyro compass is that it is not affected by magnetic field. It is responding to the gyroscopic forces, and it does require a ballast as opposed to a gyroscope.
Yeah, it's comparing to the vector of down, and then what it's trying to do is align the axis of the internal spinning mass with the axis of the Earth, which is why you've got to calibrate to latitude, because at the equator it's parallel, it's perfect. But as you get further and further north or south, the angle is getting tighter and tighter. So my understanding is that winding it round, I think, I need to check this, I think it actually tilts the whole basket, the whole assembly tilts up a bit, so it's a bit easier to align it with north while keeping the faceplate still flat and horizontal.
I'll tell you, I'll read it right here. This is from Science Direct.
Mm-hmm.
Without damping, a conventional gyrocompass would seek north but never settle there. It would repeatedly overshoot true north and oscillate back and forth around the north-south meridian, so its indication would be unstable. It would never, it would basically continue to overshoot it.
Yeah, so it has oscillation.
So let's clarify. Hang on, let's clarify this.
It represents Earth's.
So let's clarify this. Hang on, Tayler.
Surface
you said it was
is what it
round and round
represents.
in a circle, and I said no, it would waggle back and forth, right? And I offered you about. You're glad you didn't take it because then you went off and found it would waggle back and forth. It's not very good. Exactly as I said, it takes a long time to find north and doesn't settle very nicely on it. Where if you apply damping, it hunts there a lot easier.
So it would actually overshoot, and some. I suppose it would depend on how hard that it's shooting, how much how fast the precession rate is. Because if it's fast enough, it seems like it would go in a circle, which I've heard does occur without the damping.
No,
it says it would oscillate around it forever. It says it would oscillate around it forever. Says it would oscillate around it forever.
It's still finding north though. It's still it's like if you're pointing north.
It's like oscillating to the left and right. It's going back and forth.
Damping is what makes that process actually converge on north instead of oscillating around it forever.
Exactly. So you're right there, Witsit. I need to pay that. It's like its finger is pointing to the north, but it'll waggle back and forth between -3 and +3 degrees. So it is hyper accurate, but kind of waggly, so not precise, or whichever way you say that. Like at any given moment, it's not correct, but it's still locked on target.
Left and right oscillation.
It's not looking left, right? It's not looking south. It doesn't get confused what direction it is. It just can't point at it very accurately until you apply damping.
Yeah, it's a left and right oscillation.
Doesn't spin in circles. Your whole case is just void.
It can't actually spin all the way around and just continue spinning.
Yeah.
It has different effects depending on where you're at, how strong the precession rate is. But it'll never actually find north without the damping. And there's also latitude dependent corrections, which is another external factor you have to correct for in the gyro compass.
Sure. Yeah, as you.
Someone is doing a whole presentation on this, I think, tomorrow, by the way.
Okay, what time?
Gyro compass. I'm not sure. I just think he said he was aiming for Fridays. Well, no, he said he's been working on. No, but he just told me his next prezi that he thinks he'll be ready by Friday is gyro compasses.
So you said it would just spin in a circle.
Yes, stronger polarly tuned control. The azimuth area tilt area becomes about 90 degrees out of phase, the signature of gyroscopic motion. The tip of the spin axis can move in an ellipse around the equilibrium orientation.
It says how much off it'll be is based on where it was when you started it.
So do you guys think that this does lock on and give a pretty good idea of where north-south is?
I do. I think it does, but
yeah, I don't think anyone's disputed that. No one's disputed that.
Yeah, I just hadn't asked.
Well, the thing is, even regular magnetic compasses need calibration on your latitude, or if you're in the south, there's counterweights. Like, it's not a big deal. Like, otherwise, because there's magnetic dip, right? Depending on where you are, and you need to put like a little counterweight to level out the needle so it doesn't point towards the ground or towards the sky, depending on where you're at.
Yeah. It's a very fun one. I didn't know that until like a year ago. That if you take a north hemisphere compass and try go orienteering in the south, it'll be really hard to use because it gets stuck against the glass. Because the weights
I
are
don't
the
really
same.
see the argument right now, like with gyrocompasses.
Just to clarify, it's saying.
Well, they
Go
detect the
ahead.
rotation of the Earth and align with it, and that's not possible on an Earth that's not rotating.
Wait, I just want to correct something that's been said. Talking about this 3 degrees and stuff. For it to be 3 degrees, you would have had to start it within 3 degrees of true north. Like
No, you
literally
don't.
how much it oscillates.
I'll check you on that. I'll check you on that.
Okay, sounds good. Because this is
So
what
you
it's saying right
just
here. It's saying if you start it within 5 degrees of north before releasing it, it will oscillate 5 degrees east of north, back through true north, and 5 degrees west of north, back through true north indefinitely. If your starting error were 20 degrees, it would swing plus and minus 20 degrees instead. The amplitude is set entirely by the initial misalignment, not by some fixed property of the instrument. This is the same
hang
reason
on,
a
are you
pendulum
still
released from
testing
a
a
wider.
bad? But like, are you
What?
just again going, if they made a gyrocompass poorly, it would work poorly? Is that
No,
you testing a
no,
badly?
that's not what I said at
Okay.
all. It's based on where
Okay.
you start it. So like the oscillation window is based on if you start wherever you start it. If when you start it, it's a little. If it's 10 degrees off north, that oscillation is going to go 10 degrees plus and minus. So it's based on how misaligned it is. Originally, it isn't just a 3 degree error. It's not. It's nothing like that. It's
Are you
infinite
watching my
error.
stream? Are you watching my stream? I can show you that's false. This is FE Core, the guys who did the Lake Balaton, super accurate laser aiming device stuff, where he does exactly that. So he gets the thing and he aligns it to north. So he finds north initially and then he draws it on the wall so he knows what it is, and then
Why?
sets it up so it's facing east. And
Why would he
then
do that?
because he
I
wants
thought
to
it
see where it detects north the first time, and then he points it so now you can see east is where north should be, and it goes back, 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 back. And does it overshoot? I've not watched this. No, now it's slowing down. It's gone past. It has gone past by 10 degrees.
Is this
And then it's come.
Is this a gyro compass? Where's this spinning?
Yep.
This is obviously
Yep.
doing
The
the
inside.
damping thing, bro. Like it's
This
obviously
is the
damping,
inside
right?
of it.
That
Yeah, sure.
the whole point.
It uses
We're
damping to work
discussing if
effectively.
we're discussing if you didn't have damping, it
Why would you
wouldn't do
make it
that.
ineffectively?
Well, that was the
Why
whole
would you
point.
make it
You
without
claimed
damping?
that if it didn't have damping, it would still be pretty accurate. It would just be like maybe 3 degrees off. That isn't true.
Which
It'd
it
be
is.
infinite
It's just
amount
a
of degrees
bad
off.
way to do it. Why would you do it
Okay,
that way, though?
so
It would
Bruh.
still work, but it would work really poorly, which
You
is
have to
why
apply
they
It
don't
wouldn't
use it
still
without
work.
damping.
It wouldn't work at
You
all,
have to set a
Riding.
rotating
It wouldn't
body.
Fine. If it
work.
wouldn't work at all, if you break it, it won't work. What are we arguing?
You have to
you
apply.
just
What are
argued
we
it would
arguing?
work. It's so stupid we had to
Fine, it
argue
wouldn't
it, but
work.
it's because you
If you
kept
made it wrong, it
arguing it
wouldn't
would
work. I
work.
agree. If it wasn't a compass, it wouldn't be a compass. I agree. I'm happy to stipulate to that. I'm so sorry if I led you astray, thinking that if it wasn't a
No, do you
compass,
know
it
what the
Relies
wouldn't
on its
work.
damping is?
dampening.
So does it
Do you know
find
what the
north though? Isn't that the more interesting question? How
No,
does
it
it find
doesn't
north?
find north riding. It's gonna oscillate, he said.
The raw
Okay,
machine is
but we just
competent.
watched it, didn't we? Let's watch it when he points it due south.
Yeah, it'll find north
It's gonna
with the dampening and the latitude corrections.
Oh, now
with
he's doing
the
it
extra.
west. So now he's doing it with. So okay, so when we do build it right and we've got damping in it, then it works quite well at finding north pretty quickly.
The way that we use it in real life is we already do everything we can to determine where true north is, and then we align it with that as close as possible, and then we start it and we let it correct itself out. Try to get to
With the,
north.
do we have to input latitude and longitude? Like, are they this damping preset thing or setup thing? Is it doing any presupposing in that setup?
Sure, yeah. I mean,
Pre-calibration,
you're
yeah.
presupposing that the globe is spinning, and you're trying to align with.
Okay, well, I'm
with
asking
axis of
him,
latitude.
Riding.
Yeah.
I'm asking him. I addressed Witsit, sir.
Oh, sorry.
Well,
Yeah,
the
so if you put it, you have to calibrate it with the latitude, and then it
You do have to calibrate it.
Yeah, with the latitude, and then the dampening of this is basically accounting for the downward vector to try to help align it to north, but it has to have your latitude.
interesting. So we still see it spin through other.
It still roughly finds north when it doesn't have your latitude. It's just it hunts back and forth. It's less effective at finding it. I think they've got another video on it, but I haven't found it. Maybe I should just take a look. Where they try the miscalibration.
So the mercury, there was like mercury veins that we're using. But in the manual that I was just reading from on the gyrocompasses and its error calculations and stuff, they said that wasn't very accurate. I think that they do it all electronically now.
Do which all electronically?
Damping. That's aside from the latitude.
You want to give it the best shot, right? It's if a device works, you'll keep getting better at making them better.
And at 15 or 10 degrees near the poles on both sides, it doesn't work. It's not accurate at all. So this whole idea that it's just like a one shot, super easy, like it's way more complex than that, obviously.
But if it works on the rotation of Earth, then that would be the case, right? Because if you see the mechanism in here, it's trying to stay horizontal and detect a axis that is also horizontal if you're at the equator. But as you're at the pole, you're trying to detect something in a horizontal fashion and tell you where that is horizontally when it's vertical and popping up out of the ground right next to you. It's a very different, your vector is now almost zero. Like the amount of torque it's giving to that vector is getting less and less. If that makes sense. It's if the Earth was turning, that's what should be the case. It should get harder to detect it as you approach the. And a certain gyroscope would still work. It's just now you'd be detecting that you're turning around horizontally, like it looked like Witsit was doing when he went down to Antarctica. It looked like he was standing still on something that was turning around, and he was on the bottom of it, or the top.
Why do the gyro compasses work best at the equator, but the pendulum does not persist at the equator?
I don't know. I don't really get the pendulum, but I can understand a torque left and a torque right being different if you are perfectly on the equator. But my understanding is they're very, very difficult to set up well and are often subject to a whole bunch of other forces that just mean that they're a museum exhibit. They're not a good detection device. Nobody uses them. That's why Leon Foucault gave it up and made the gyroscope, and we still use gyroscopes today. They're better at detecting rotation. Does anybody here think that a gyroscope that could detect
Riding. Well, do you think that if that gyroscope was like in space, it would be oriented to the most dominant gravitational body it was close to?
No, so in space it will lock onto free space, like it'll look at the background
But
stars.
on Earth, it doesn't lock onto free space?
It does, yeah, absolutely.
Okay, so on Earth, it locks onto free space, right?
Yeah, it's like if you look at your whole.
So you don't only get, because I've seen them pour through this data. I've asked, they've said it's like, I've heard guys go like, it's their titty hairs, but I've not seen them do it. But like, if you're saying it locks on a free space, we're going to get Earth rotation, Earth orbit, sun orbit, all that, right?
Does it lock on, or do they use that as a reference point?
It's not doing either. It's just a way to say it. What it is because you're increasing the inertia along a rotational axis, you are making yourself incredibly sensitive to any disturbance to that, and are really unwilling to change from that orientation. And so what that will mean is in free space, you don't have any position. Like if there's nothing else existing.
I can't follow all what you're saying. I presented a simple yes or no for you. I'd like to know if you're leaning yes or leaning no.
It's rotation. It's different to movement in free space. It's still rotation.
So yes or no?
You're locking on to
yes or no, or
free space. Just say free space. Yeah, just say maintaining an absolute orientation in free space.
Oh, it'd be great. It'd be great to see, the Milky Way drift on one of those things.
Yeah, what does that even mean? Because there's free space everywhere.
Sure, and it's just it is it will lock onto an orientation ignorant of anything out excluding
We
it.
need to put those we need to put a grid of those everywhere in the universe, and then we'll know the absolute coordinate system.
I mean, it seems like they do that, don't they? You've spun a bicycle wheel. We don't need to get highfalutin with the relativity. We spun a bicycle wheel.
When they dug through, when Bob Nadell came in here and Jeremy fucking pounded him for the data, and then the Glober guys and Gems, and oh God. Anyway, when they poured through the data, they were like, I was like, well, so you can see orbit in there too, and they were like, yeah.
So stupid. That's so stupid, dude.
They told me that, Witsit. I'm not lying.
Yeah, but they're stupid, dude. You have to throw relativity out. You can't detect anything to do with the orbit on Earth. We just went through that, but like basically what they did was they went so over the top trying to be so precise and get all the measurements that they calibrated it with such an insane sensitivity that it just threw so much noise in the data and then auto-corrected that it was effectively useless data.
They wouldn't
Bob's data,
show it. They came back. They just reported, right? I just remember them reporting. Yeah. I don't. They didn't teach us laymen. Like, look here, look here, look here. They just testified.
So Stone does the best breakdown of that I've seen, where he goes thoroughly through all the data. Stone from Ether Cause, and he shows the issues with it. But yeah, I mean, anyone claiming that you're detecting anything to do with the orbit is insane. All I know is like I haven't gone like fully deep dive into gyrocompasses, right? I understand that they work, and downward vector is not exclusive to anything. Inertial forces of rotation is not exclusive to anything. Like same with the pendulum, same with the gyro. And then as we get higher and higher, like when we detect rotation, it increases with altitude. Like throw Bob out, but Dayton Miller did that, And so we can detect the motion of the sky rotating around us. I don't really. So if you imagine a plane Earth with a rotating universe around it, so it has like a vortex centered on Earth, then there's going to be an angular vector to that rotation. It's going to correspond to latitude, and you're going to have real inertial forces translated down to the Earth. None of this would be exclusive to a spinning globe if it all works like exactly like it said. But I know Alan is like autistic when he decides to look into something, and he's gonna do a presentation on it soon. So like I would just watch what he presents and then go from there. I'm not gonna deep dive into it just to overlap with him. He's supposed to do a prezi on gyrocompasses in the next day or so. So
Thanks, man.
yeah. Yeah, but the orbit claim's crazy, bro. Like Eggshells kind of venturing towards that. Like I've had a couple other people try to tell me that. Yeah, and it's like, dude, it's just that is fundamentally against what relativity says. It's literally impossible to detect anything to do with orbital motion. No forces, nothing like that.
Well, the
So
rotation is my claim, and that's the one that needs addressing.
Hey,
gyros work, and is it just one more day? Is the only question worth asking on
Yeah,
that.
in your world, Earth is rotating around the sun.
It doesn't touch relativity. It's just an object rotates 365 or 366 times, or sorry, 364.
no, that's just based on the sidereal and solar day. The sidereal day is 23 hours and 56 minutes. There's a 4-minute difference. 4 minutes over the course of 365 days is going to give you one extra day. That's all that is. But it's fine. Yeah, like the rotation, I've addressed it. Whatever, you just say, it's fine. But you should be happy because I've heard you talk about this for 2 years, or at least Alan's gonna supposedly fully cover it. So he said he found some crazy stuff.
I'm going to guess it now. We will spend so little time talking about mass, rotational velocity, inertia, gyroscopic forces, precession, and rotation, and necessary consequence of being on a rotating body. And all it will be is the same as it is today, which is endless discussion about irrelevant relativity shit.
I'm glad you know relativity is
relevant.
relevant.
I'm gonna call it now and say Alan. I'm gonna call it now and say Alan understands the gyrocompass at least 20 times better than you do.
Sure, I believe it. I just think we're going to end up talking about something else. If he understands it at all, he will not.
I think he'll still man the gyrocompass from the globe like perfectly well. He does that with everything.
Still man it, yeah. I just don't think we'll spend much time talking about spinning masses. I think we'll talk a lot about exactly what you have: fringe shift and Planck length conversions and all sorts of esoteric, mysterious, theoretical physics related to
Because you're
relativity
ignorant
and stuff.
about things doesn't make it
Just won't
esoteric.
touch
Why
us.
the
The
fact that it's
masses.
rotating makes it line up with the linear axis? And what's the fundamental mechanism?
I would say it's like I could feel it better than I could show it, in that if I had a spinning mass and I felt the gyroscopic forces or the precessional forces from tilting it, and you said, hey, if you were on something spinning, do you reckon you could line those up? I think I would go, oh, not the first time. But if you gave me a couple of $100,000 and a bit of time in my garage, I could think I could figure that out, yeah. Could you make a thing that detects rotation? Not a gyrocompass, I just mean a thing that detects rotation. Once I'd figured out gyroscopic forces, I could do that, yeah.
Yeah, but Earth
That's
is
what I mean.
rotating around the sun, and you can't call it linear. You can't call it a linear orbit without relativity, and you keep abandoning relativity.
I don't abandon it. I say it's probably true, but I just don't need it in my argument. I don't invoke it. You guys do. It's not related to rotating objects. Can you tap in, Ruhif?
The only
You
way
think
you
it
can call
matters
Earth's
if you're
orbit around the
looking
sun
at
linear
something?
is because of relativity, right? So it's actually a rotational motion,
No, because I
like
don't
a
think it's
ball
even
around a
needed.
tetherball pole, right? It's a rotational motion.
Magic way to
So
make like
classical
shift if you
mechanics,
were looking at it.
you'd have observable effects from that, right? So you need
So
Right,
I don't
relativity to
magically
think.
explain
knows if
why we're
you're
not
looking at it.
detecting any of that.
So I don't think you need relativity until you get outside the solar system. So I just disagree with that. I think that the idea
So you
that
can
mass.
explain MMX without relativity is what you're saying, which everyone knows you can't.
No, if I was saying that, I've got a neat trick, and that is I say it, but you
Right, well,
change
that's
the
an
topic.
experiment
You
that took place
always
on
won't
Earth. So what
discuss
you said
what the
about
topic
only
is.
needing relativity beyond Earth or any terrestrial experiment was that was wrong.
I didn't. I just said I don't think you need it to explain anything until you get to the edges of the solar system, really,
And
for
where did
me.
MMX
Obviously,
take
within it,
place?
you
It took
do.
place on Earth, right? It was a terrestrial experiment, right?
Sure. So some things do
So you
become
do
relevant
need
once.
it for Earth. So you
I
do
don't
need
need
it.
it personally. I mean, satellites
Right.
need it, but
Well,
I don't
it's
think it
relied
does.
upon. It's relied upon to explain why Earth is in orbit around the sun.
Sure. I don't need it for what
Without
I'm saying about
relativity, you can't
rotation.
explain that, right? So you can't explain
Sure.
like the
I
basic
can't explain
fundamentals
things
of
that
your
aren't
model.
related to my argument. Yeah, they're not part of it.
So I still don't get the answer about. I mean, you said you could feel it better than explain it. I mean, I still don't understand your answer.
Do you think a gyro on a plane could detect that it's doing a barrel roll?
Sure. Yeah, I can keep its position in free space.
Sure. So at what point, how slow a barrel roll do you think would be impossible for an infinitely precise gyro to detect?
Is this series of questions supposed to answer my question?
Well, we're reasoning to it, which is,
I'm not sure.
I think that 15 degrees an hour or one rotation a day is detectable. Do you think that we can detect a quick barrel roll? What's the slowest barrel roll you think before it's impossible humans could detect it?
I just answered.
Oh, what is it? What was the answer, sorry?
So I'm not sure.
Okay. Do you think it could be like if you did a rotation and it took you half an hour, we could still detect that with a gyro?
I'm not sure.
Maybe. What about if I could show you gyros online sell for tens of thousands of dollars that give you this number about how precise they are? Okay. Do you think that if I found you a $15,000
You think you can just
gyro?
explain it and stop asking me questions?
Sure. I think that if I found a $15,000 gyro and it didn't detect with very high precision like it would say on its specifications, I could just buy that gyro for a minor cost and sue that company for false advertising because they're selling a device that doesn't do what they claim it does. So I think just by knowing that gyros claim to have very high precision, you can be quite confident that they have such a precision, because otherwise they'd get sued. They wouldn't be in business. They'd be selling lie devices and very good. So do you get the reasoning I'm making? If gyros exist that claim that they measure that precisely, it would be wild if they weren't correct. Or do you think
I
gyroscopes?
mean, everybody thought MMX would have been decisive.
Mechanism.
Like nobody, Einstein,
the mechanism is
Michelson, Moreland, everybody thought it was going to be decisive. They thought it was even more precise than it needed to be.
But
The question is about gyroscopes. Do you think that gyroscopes could be a lie, or when you
best
find
proof
an expensive?
When you're talking about gyroscopes, you can't even explain why it precesses off the Earth's surface. You don't know how gravity affects it. Like
I don't know what that means.
you're just out of your depth.
Yeah, I'm out of my. That sounded like it not related to what I was saying. Didn't answer my question. Just said some weird words. Do you think that there is a minimum amount that a gyroscope couldn't detect? Like, what about if you did one revolution every 10 years? Do you think I think it's probably impossible to make a gyroscope that precise. It could measure one revolution per 10 years. But maybe they could, I don't know. But I'm going to guess that they could detect one per day. Would you agree that it is possible that there are devices out there that have a claimed precision of more than 15 degrees per hour?
Is this your way of explaining how it works? Just continuously ask questions?
Oh, I said how it works. Talk.
Torque is one word. That's not an explanation. Would you be
so rotational,
if you asked me for an answer and I gave you a one-word explanation?
Okay, rotational force. Rotation is applied to it through whatever, and that is how the axis can be brought. It can intake those newtons of force, and that will cause it to seek or like hunt or feel out of kilter until it aligns with the axis of that torque, that rotation.
So if you fly west to east, would it process quicker to find north?
Yeah, so you've got to. You also should put in the ship's heading and speed, because if you're sailing east versus sailing west, you are doubling or halving not doubling or halving, but doubling the difference fore and aft of the Earth's rotation. Yeah.
I just do we have proof of that happening? Or just
commercial shipping?
Yeah, the processing quicker part. If you go with the rotation of the Earth.
I don't know about it processing quicker. I think I think it is pretty good at staying locked on, like always pointing north. It doesn't suddenly point to the west. It just does a hunting move, or I think more.
There's a measurement that Wolfie did, Eggs, that he weighed an object traveling east and weighed an object traveling west, and it weighed less traveling east.
That's interesting because it's going downhill.
If you fly against the rotation of the Earth,
higher centrifugal force.
Go pretty quick. Would it not process at all to find true north if we're flying against the rotation of the Earth?
Say it again, sorry.
If we're flying against rotation of the Earth, will it not process the north?
Yeah, so essentially you could cancel it out entirely. If you took a gyrocompass on a plane and then flew eastward at the equator, staying with the rising sun, it wouldn't be able to detect any direction. It would have no access through it. Yeah, I don't see how that would come to pass, but it would be good proof. But I don't know anybody who could do it that could be trusted once they did it.
So just so you know, Andre's
it was processing when it's not attached to the rotating surface. Gravity is moving the plane.
Say again.
Like, what was your explanation? How is the mechanical gyro processing when it's not attached to Earth's surface? For example, like in a plane.
Yeah, that's what I'm saying.
Gravity's rotating the plane and the gyro, or what?
Yeah, so you'd have to account for its change. If it's cancelling out or adding to the rotation, or it's going to be moving from A to B, that will affect it, yeah, because it'll be moving in a linear path across a curved surface, so it'll be doing a part of a rotation itself. But it's like vector addition, where you just go, well, if I'm tilting and rotating this way and I'm moving in a path that's rotating me that way, I think you just kind of angle out. What do you do there? I forget. I think it's just you angle out. It's like vector addition, but with an axis. How do you do that actually in physics? But yeah, it's just
because I thought like the mainstream explanation was the plane is within Earth's gravity well, so it's
that's not mine. No,
ever so slightly rotating the plane and the gyro. That's how it's processing.
You'd have to go with the person who gave you that answer, because I don't give that answer. You're going to have to deal with my ones. I'm sorry.
So it's just like the momentum. So you take off in one direction, and then when you change directions, it's not going to process anymore. In your scenario.
I think so. Yeah, I think if you took off at an equatorial airport heading east, a gyroscope and a gyroscope would detect no rotation, and a gyrocompass would not. I don't know what it'd do. I don't know what its behavior would be, whether it would just keep going around in a circle or just kind of do nothing. Whichever way you spun it up, it stayed pointing. I don't know what it would do, but you would have cancelled out the one torque or force that was being imparted on the device that was letting it find
So
something.
they're useless pretty much in planes. Like gyro compass are
Yeah.
useless in planes.
Yeah, you wouldn't use it in a plane. You use a ring laser in a plane.
I mean, I was Googling, it said gyro compasses still persist in airplanes. They use them on airplanes.
Oh, okay. What airplanes do they use them on? Because I thought they were quite sensitive to vibration. They don't like changing vector or sort of orientation quickly, I thought. Which is what planes do, right? Where are gyro? Where? There's going to be some cool use, isn't there? True mechanical gyrocompasses, are rarely used in standard airplanes. Yeah, directional gyroscopes might be what you're thinking, which is when you start up the plane, you'll lock this thing onto north and swizzle it for declination, but then that track is held by a gyro. So it's a gyro compass, but it's actually a gyroscopic heading indicator where it just stays locked on where you teach it on the ground.
So that wouldn't persist due to Earth rotation.
That one, all of them must detect it. Like a torque goes through everything. It's just gyroscopes are better at detecting it. But yeah, it wouldn't be a good tool for detecting Earth rotation, I don't think. Because I think they have, certainly the one that's the attitude indicator or the wing to tell you if your wingtips are level, that has some extra little vanes or lets air in some funny way that means that as you turn it just keeps averaging out, I think, what down is, what level.
Yeah,
looks like.
I'm seeing that older airliners, Boeing 737, 747s, use them. I guess the modern ones, they use laser gyros now.
Yeah, they could have used them in back in the day.
So but yeah, mainstream already has an answer for it, so no need to.
Yeah, it does. The Earth's turning.
Right, so the plane is within Earth's gravity while everything's slightly being
To
affected
your
by that
one,
rotation.
that's not my answer. I'm not. If that's it, you'll have to go and talk with Mr. Mainstream. My answer is that the plane's flying level, and if that level that it's flying level to is turning, then it'll turn with it. And I don't feel
When you're not attached to Earth anymore, you're not going to be detecting Earth rotation.
Right, but is the Earth still turning?
It doesn't matter.
Okay, so you've taken off and you're a tiny little speck of dust on this giant turning thing, and then what would happen next if the Earth was a turning ball? What should happen?
Like you said, the gyro's going to keep its orientation in 3D space, irrelevant of the Earth. See, if you were on the Earth and the Earth was turning, it would go, "Oh, look, we're turning." But now, since you're in the plane, it's going to tell you what the plane is doing relative to everything else in the universe, all the way to the edges.
Yeah, actually, sorry, you bang on. Exactly right. Yeah, so the ring laser gyro, when the plane takes off, is locked in its orientation and will detect its path, the average between its path over ground and the rotation of the Earth and any other rotation it goes through in that flight, such as like bang.
They've tried to use gyroscopes to see if the Earth is round or flat, because gyroscopes. Not talking about gyro compasses. I'm talking about gyroscopes. So their job is to maintain the rigidity in space, right? So if the Earth is a globe, or if it's curving, then the gyro should technically, right, maintain its rigidity. And as you start to move around the curve, the gyro will start becoming slanted and more slanted and more slanted.
Yeah, but there's difficulty
doesn't actually
with that,
happen.
right? There's difficulty with that because you should also be turning with it at 15 degrees an hour, and it would be difficult to cross an ocean so quickly that you would see the tilt from the curve of the ocean that wasn't completely overshone by the tilt of the turning in a complete circle over 24 hours. Right?
Yeah, you're
So
talking. Well,
but what you do get in these devices is exactly that. So what I expect you would get as a raw readout if you read a long haul flight log is you would get all of the tilt and rotation and turn of the flight path, but I think you would detect that that flight path is curved in an arc nose down, and you would detect that the Earth has turned during that time such that there is a standard eastward 15 degrees an hour. All of that
no, yeah,
data
but
would be in that.
that's a separate argument. Now you're talking about the torque of the rotation, right? We're not talking about the torque right now. We're just talking about what gyros normally do is keep their rigidity in space, right? Now we can talk about the rotation. That's like a non sequitur. It's what I'm talking about. Because just the gyro alone, dude, right, should be turning. It would be perceived to be turning as you move around the curve, right? But it doesn't do that. If anything, that would be a proof for flat Earth. The torque.
Again? I'm not followed.
The torque is a separate topic, right? The gyro could still process, right, and also keep its rigidity in space.
Dude. Okay, this could be wrong, but I'm reading that
I don't know what that means.
for the horizontal north-seeking Earth rate component at the equator, it is always 15 degrees per hour, regardless of whether you fly east or west, assuming you remained exactly at the equator. But they do have a wandering effect that will happen whenever you're traveling east or west, like an air correction mechanism you have to apply, but that doesn't apply at the equator.
Not sure that's true. I think it does apply at the equator. It's least to the equator because your diameter is the biggest, so you're traveling the fastest. So if you were traveling like 300 kilometers an hour, let's say, at the equator, you'd still be traveling 700 kilometers an hour the other direction. So its effect would be tiny. But if you were traveling 300 kilometers an hour, latitude way down south, the lines of latitude are much smaller. So yeah, it's got a big effect at what latitude, in what heading, at what speed, because that will be affecting the rotation, either adding to it or subtracting from it.
Look up if the precession or torque is always 15 degrees per hour at the equator, no matter which way you travel.
I don't know what that means.
It's
we just talked about if the north.
It doesn't sound like what I said though. I don't know what you're testing.
Why are you talking over me after asking the question?
Sorry. Yeah, what are you testing? What's the question?
Remember how the precession rate is 15 degrees an hour to find true north at the equator.
Right.
Okay, remember how we just talked about if you fly east or west to east, if that would be affected, the ability to find true north, because you're moving and spinning away from the Earth's rotation.
Yep. Yeah. So if you cancel it out, my argument is if you flew eastward at 1,000 miles an hour, so roughly you just kept the GPS, flew in the sun's GP, let's say, then your rotation would be 0, and the gyrocompass wouldn't be able to find north, and a gyroscope would detect no rotation.
So there is a wandering effect where you're traveling east or west or east, so they will take into account. But apparently at the equator, the direction you're traveling does not affect the precession rate.
Yeah, well, it's wrong, or you've asked it a weird question, I think. Or I'm wrong, but I don't think that's right. Yeah.
Hey, you guys are still going on about that, but I know Jesse, the Path of Light, he's talked about, we've had this conversation multiple times before regarding gyrocompasses, and the argument is the reason that the gyrocompass doesn't become slanted as you travel or traverse over the Earth is because the bearings aren't fluid enough, right? It requires like a really, I heard this, the excuse was that it requires like a really expensive gyro, and the ones that you can get like on Amazon don't fit the bill, because the bearings aren't sensitive enough, so it doesn't actually pick up the.
But I think
whatever it is,
if you wanted to know it, I think first step is you would just compare a very expensive mechanical gyroscope to a very cheap fog, and go, because a fog you can buy, if you want to do a bit of Raspberry Pi and build something yourself, a fiber optic gyro you can get as a little chip, and they go in drones and RC cars and phones and all sorts of stuff. So they're really easy to get, which is just a gyroscope that tells its change in orientation in 3D space, and put that into a board. And if you test that against an actual gyro and you become
those are gravity based, man, if they're that tiny.
But if you just become convinced that a fiber optic gyro works, then you can just use a fiber optic gyro to test it. You don't need the.
Oh, but eggs. But you see what I'm saying though? Like, you're talking about antipodal, right? If you've traveled from one position of the Earth to the other position, antipodal, and the gyro keeps its rigidity in space.
Yeah.
Theoretically, right? If you're on a globe, the gyro would basically would be upside down by the time you got to the other side, or not not entirely upside down, but pretty much. But that doesn't happen.
You would be able to work out your latitude.
Pendulous
That
vanes.
does happen.
Pendulous vanes correct the orientation to down.
Oh, in the
But
plane
apparently
ones.
there was a time they flew without pendulous vanes. They were patented after the first aircraft.
Yeah, but we're going back to the D Marble thing. Like, he sat on there, didn't he? No, he had his phone, right? He was doing his phone, I think. But we're like pretending he's like spinning up a freaking rigid gyro. And I think, Lion, you're saying Jesse said there was too much friction in these things. And that's why, like, I'm like, how do you keep them spinning for an hour? That's where I'm at. Like, a rigid gyro, it ain't gonna do nothing.
If you do it slow enough, if you do it, you can actually tip it or whatever, or spin it. If you do it slow enough, it'll keep its rigidity, without actually like they demonstrated a video, dude. I don't know how to explain it. Like, if you do it slow enough, right, the rate that you're traveling, it's so nominal that it's not going to affect the gyro. It's going to keep it's just not going to move. You know what I mean?
Yeah. Zion, what do you think is the slowest rotation that you would trust a gyro to detect?
Oh my gosh.
Dude, I don't know, man. But basically, it doesn't work. At these scales, these gyros don't work. They're not sensitive enough. So, though they're supposed to keep their rigidity, they continue to actually.
Which ones?
The ones that you get on Amazon for a couple $1,000.
Oh, yeah.
They don't work because the bearings aren't sensitive enough. That even though it should keep its rigidity, it doesn't actually keep its rigidity in space when you go around the curve of the Earth.
Yeah, I think mechanical ones are a very expensive bit of kit for that reason, and that's why I'm saying if you just become convinced that a fiber optic gets the same results, then you can, anytime you use a fiber optic, go, well, I could get that $40,000 mechanical gyro to test it, but I'm so confident that the fiber optic does the same thing, I can spend $40 and do it in a weekend.
So
I don't remember.
It's looking for a phase shift. It's not. I don't know if it's like north seeking. I don't think so. It just has a phase shift. But I was gonna ask you a question about the mechanical. How many revs per minute does it have to rotate to be effective, and why does it have to rotate so quick to find north?
Because it's a gyro. You're saying, like, why does a gyro have to spin? Is that the question?
What rate does that have to spin at to start working?
But is the question, why does a gyro have to spin? That's what it is. It's a spinning thing.
My first question is.
But she didn't ask you that, Riding. She said, why so fast?
Oh, I don't even know the RPM.
I'm still trying to get an answer out of him, dude. Like, I don't even know. I really don't know the excuse. I'm trying to remember the excuse. I don't remember the excuse. Do you have an excuse for why the gyro compass doesn't keep its rigidity in space when you travel around the Earth? Now, I heard this guy talk about the vanes. Oh, let's say that it doesn't have vanes. What's your excuse then?
Like, I don't know. I think that if you've got a small gyro that's job is to detect moment-to-moment rotation such that in a whiteout it could keep the plane level, but it would not want to detect rotation. So it's the same question essentially Tayler was asking before. You're saying, why don't we build a device that's job is to tell him if his wings are level when he can't see the horizon? But why don't we deliberately build it in such a way that it's wrong after 12 hours?
No, just don't apply corrections.
Yeah. So why would you do that? Why would you build a device that was meant to do one thing and then make it shit at just that one thing?
So why can't you answer the question?
Because you wouldn't build a device that doesn't do the thing it's meant to do. Whatever way you build it,
You're
build
saying
it,
that,
it works.
okay, so we have to acknowledge the basic device can't do the thing. You have to apply corrections to the device.
What does that mean? You've got to make a device that works.
Not detecting anything.
You know,
what is it doing then?
You know exactly what it means. That the device in and of itself can't do the thing, right, Lion? You have to apply corrections to the thing. So he's asking you, without pendulous vanes, could it still maintain rigidity?
Are pendulous vanes part of the device, yes or no?
No.
Oh, then we're talking about something else. I'm talking about an airplane gyro and we're talking about pendulous vanes, whereas an RLG won't have them. I don't think the ring laser gyro has anything that you call pendulous vane, but it isn't spun up with air, so it's a different thing. Like the ones in a plane are spun up by letting some air in the nose, and then the velocity of that air spins around a gyro in there, and then some of that air is like valves open and close over time, just gently bringing it back to a kind of average of what's horizontal and the vector of down, I think.
If you don't know the answer, it's fine.
I just did give you the answer. The pendulous vanes are part of what I would describe as the device, and they're there because otherwise the device would be broken. What's the question if that's not the answer?
No, it's not the answer. Pendulous vanes are not part of it.
They're not part of what?
Lion, re-ask your question so I don't butcher it. Okay.
No, I was saying regarding not the gyro compass, dude. Just regular gyros. If you're in a plane, dude, right? It's supposed to keep its rigidity in space. Why doesn't it keep its rigidity in space? And I'm not talking about the ones without being.
Even
like theoretically, if you were to use a $30,000 gyro, that was.
I don't know if gyroscopes have a vertical. You know, I don't know if they behave like
that. I just don't like. I don't understand the question when you're saying why don't they do that? When you say they, there are millions of kinds of gyros. So in